November 11th. Once again, astronomers have uncovered terrifying new secrets as 3I, Atlas continues to plunge toward the Sun in a series of relentless collisions. For days, reports of violent interactions between 3I, Atlas and the Sun have spread across the scientific community, yet each encounter brings not destruction, but revelation. With every impact, the object unveils another secret. Laws once thought unshakable begin to tremble, and in the space between fact and possibility, something extraordinary begins to take shape. A question. Has nature just revealed a new law, or are we witnessing the trace of something that was made from the cautious hypotheses of Avi Loeb to NASA's prolonged silence, from the delayed release of images by the Mars Reconnaissance Orbiter to the calls for transparency from the US Congress? The story of 3I Atlas has long surpassed the boundaries of physics. It has become a mirror reflecting the human mind, how we confront mystery, cling to knowledge and tremble before the unknown. And so right now we turn to the latest findings and official reports to explore what astronomers have discovered in these recent days as 3I the Atlas, the interstellar wanderer, continues its dramatic dance with the Sun. At first, 3I Atlas looked ordinary, a dim interstellar wanderer following its path around the Sun. Then almost overnight it changed. 3 days ago as it passed, perihelion telescopes recorded a transformation no one expected. Its brightness increased 5-fold, yet its structure refused to behave. Instead of a single tail streaming away from the Sun, the object released multiple jets in different directions, a tangled geometry of light and motion. And the most recent research shows that one of those jets, the strangest of all, is headed straight for the Sun. No comet should do that. In classical physics, solar radiation pushes dust and gas outward, forming tails that always point away from the star. To resist that force is like watching a river flow uphill. Yet here it was a plume of gas defying sunlight itself. At first, the discovery was dismissed as error, an angle misread an illusion of scattering. But as days passed, the anomaly persisted. Observatories from Chile to Hawaii confirmed the same behaviour. The jets were stable, not chaotic. They formed a pattern that repeated measured, deliberate, almost mechanical. Spectroscopic readings deepened the puzzle. The outflow velocity of the gas was only about 150 meters per second, too weak to resist solar wind pressure. The jets should have bent, dispersed, dissolved. Instead, they held their shape like invisible columns of energy anchored to the nucleus. Every physical model failed. If heat from the Sun caused this, the effect should be random bursts of sublimation, sudden eruptions, short-lived flares. But Atlas showed continuity. The jets pulsed in cycles aligned with the object's slow 9-hour rotation, as if responding to an internal command. To imagine it is to picture something breathing in deep space, a dark stone exhaling threads of vapor, each in rhythm with its spin. It was mesmerizing and deeply confusing. Theories multiplied. Some said the jets came from venting stratification layers of gas trapped beneath the crust, released through different cracks as the surface fractured. But this couldn't explain the stability. Others blamed rotational bias. Perhaps the comet spun fast enough to expose multiple hot zones, yet its measured rotation was too gentle. The physics didn't add up. What was left was speculation, cautious but unavoidable. Maybe the venting wasn't random at all. Maybe it was directional, guided through narrow internal channels like nozzles focusing the gas into precise jets. If so, 3I, Atlas, was doing something no natural object had ever done, adjusting its own motion. Could an ancient fragment of rock and ice possess a self-regulating mechanism, something that mimicked propulsion? It sounded impossible, yet it fit the delta better than anything else. Computer simulations at the European Southern Observatory compared two models, random outgassing versus guided flow. The first collapsed into noise within hours. The second, the channeled emission model, reproduced the exact jet geometry observed. The conclusion, carefully worded, read anomalous collimation, consistent with localized venting or structured pathways. No one claimed design, but no one could ignore the symmetry either. Somewhere between coincidence and intention, the truth waited. If the jets were natural, they revealed a new kind of physics, a way for volatile materials to self-organize and regulate heat release. If they weren't, then we were witnessing something far rarer, an engineered system that had survived for billions of years, now awakening near our Sun. The change from silence to motion, from dormant rock to active structure, was so abrupt, it felt like a switch had been thrown. From that moment, our Atlas was no longer just a comet. It was an experiment, a cosmic riddle about how matter behaves when the familiar rules begin to bend. Scientists spoke softly when describing it, almost with reverence. It's as if the object remembered how to move, one wrote in his field notes. Maybe it did not remember. Maybe it simply responded. To heat, to light, to a condition written into its structure long before the solar system even formed. Whatever the reason, its sudden change marked the beginning of a larger mystery. A reminder that even in the most predictable of systems, the universe still keeps a few surprises folded in its silence, waiting perhaps for the right angle of sunlight to reveal them. For weeks after perihelion 3, our Atlas drifted in silence. No visible jets, no optical flare, just the faint echo of sunlight glancing off its metallic surface. Instruments around the world continued to listen and heard nothing. Then on October 24th, the silence broke. From the high desert of South Africa, the Meerkat radio telescope caught something unexpected, a narrow clean signal at 6.65 GHz, followed by another at 1.667. The twin peaks of hydroxyl absorption, the molecular fingerprint of water vapor touched by sunlight. It was the first whisper the object had ever made. Hydroxyl lines are ordinary in cometary science, a sign that ice has begun to vaporize. But what unsettled astronomers was when this happened. The object had already passed perihelion. By that point, the heat should have peaked and begun to fade. Yet instead of cooling, 3i, Atlas spoke. The question was immediate and precise. Why now? If the object's activity followed thermal logic, its outgassing should have been strongest days earlier, when sunlight was at its most intense. But no signal was detected then. The first activation came only after Atlas turned away from the sun, as if some internal switch had waited for the right alignment, then opened. At first, scientists assumed coincidence. Maybe a region of volatile ice deep inside finally fractured, releasing a small burst of gas. But the spectral lines told another story. They were too narrow, too clean. A natural venting event would scatter frequencies across a wide range, turbulent, noisy. This, however, was steady, controlled, almost surgical. Professor Avi Loeb called it methodical seepage gas escaping as if through a valve rather than an explosion. It was a poetic phrase, but also an alarming one. For decades, the idea of a comet regulating its own emissions had belonged to science fiction. But here was an observation that behaved precisely like regulation. Not chaos balance, not eruption control. Could this be a purely physical phenomenon? A group from the Max Planck Institute for Radio Astronomy proposed the insulated shell hypothesis. They imagined the object coated in a dense carbon-nickel crust, acting as a thermal barrier. Heat from the sun couldn't reach the interior immediately. It pooled beneath the surface for days until pressure built high enough to crack a vent open. The result would be a single delayed pulse of outgassing, perfectly matching the timing of the radio detection. It was a clean theory, but it raised one more question. Why was the emission so stable, so calm? If a crust ruptured under pressure, the event should be violent, a burst that fades within minutes. Instead, the hydroxyl lines persisted for 36 hours, unwavering, as though the vent stayed open just enough to release the built-up energy without losing structure. It was the kind of balance a system achieves only when it knows how much to release. Some called this the self-regulation scenario, the idea that the object's layered composition allowed it to adjust outflow, naturally maintaining equilibrium, like a biological process, a thermal heartbeat carved in ice and stone. Others leaned further towards speculation. If the pattern was too precise to be random, perhaps it was something else a triggered response. Maybe the sun's radiation didn't just heat the surface. Maybe it acted as a signal. Imagine an object drifting for billions of years inert until a certain combination of radiation, the right wavelength, the right intensity reaches its surface. Inside, something resonates, a chemical lattice, a conductive vein of nickel and ancient circuit. The result is a pulse, a release, a reaction that looks like outgassing but feels like awakening. Was that impossible, perhaps? But the mathematics of coincidence were growing thin. In early November, cross-observations from ALMA confirmed the same frequency, the same pattern fading gently after 2 days. No other emissions followed. One pulse, one breath, then nothing. The data was sent to NASA and catalogued with restraint. Transient hydroxyl absorption event post-perihelion, duration 36+, 3 hours, no recurrence observed. That was all the official record would say. But among the scientists who had seen the live feed, something lingered, a feeling that the silence after the signal meant more than the signal itself. If it was a natural event, it was extraordinarily disciplined. If it was something else, it was extraordinarily discreet. Either way, the moment marked a boundary, a point where physics and wonder blurred into the same line on a graph. What turned 3i, Atlas from silent rock to speaking comet? A fracture, a resonance, a memory. No one could answer. The object continued outward, shrinking into the distance, the echo of its brief whisper fading beneath cosmic background noise. And yet on the record, those twin lines remain thin, perfect, immutable. They remind us of a simple truth that humbles every scientist. Even silence when it ends carries meaning. By early November, the calculations no longer matched the sky. The predicted orbit of 3i Atlas, drawn from weeks of optical tracking, began to slip. At first, the offset was tiny, a fraction of an arcsecond, then 4. Enough to break certainty. The object was moving away from gravity itself. Every known comet obeys one master, the sun. Its path can bend, its spin can change, but all motion follows the pull of mass and light. Yet Atlas drifted with a smooth, steady bias, as though an invisible hand were adjusting its course. No collisions, no solar storms, no measurable outgassing could explain it. When the ALMA and Pan-STARRS datasets were combined, the deviation grew undeniable. Mathematically, the force required was minus about 2 × 10⁷, ms2, but consistent. Sustained over millions of kilometers, that whisper of thrust was enough to reshape its trajectory. The term entered every report: non-gravitational acceleration. In theory, such drift can arise when sunlight heats one side of a comet more than the other, causing gas jets to push it unevenly. But Atlas had already defied that rule. Its jets were faint, symmetrical, and fading. If the thrust came from sublimation, the direction should oscillate with rotation. Instead, the acceleration vector stayed constant, aligned almost perfectly with its orbital plane. It was as if the object knew where it wanted to go. Scientists resisted that thought. They searched for hidden variables, thermal lag, mass, misestimation errors in star catalogues. But each correction only tightened the curve. The anomaly remained. A non-gravitational cause meant one of two things. Either the object was producing force from within some natural but unknown venting system, or its motion was being influenced by something beyond ordinary mechanics. The first possibility led to models of subsurface propulsion, a network of sealed chambers beneath the crust where trapped volatiles built pressure, escaping through microscopic vents invisible to telescopes. Each release would be too gentle to form a coma, yet together they could generate a steady push. The physics worked, barely. The precision, however, bordered on artistry. If random cracks were responsible, the thrust should fluctuate. It didn't. For 9 continuous days, velocity increased in a linear line, no spikes, no tremor, no noise. It was motion with intent, or at least with discipline. That word unsettled the community. Discipline implies control. Control implies design. Some whispered the comparison everyone avoided: Oumuamua. In 2017, the first interstellar visitor had shown the same gentle acceleration unexplained by outgassing. At the time, scientists called it coincidence. Now coincidence was repeating itself. Could both objects share a hidden architecture, a structure that reacts to sunlight not as heat, but as stimulus? Could thin metallic layers beneath the surface absorb radiation and release it as directed motion, a kind of photon-regulated drive? If so, it might represent a natural phenomenon never seen before, or a technology so old it has merged with nature. The idea split the field. Half demanded new physics, half demanded humility. But all agreed on one fact: the sun's gravity was not enough to describe what they saw. In Cambridge, Avi Loeb offered a calm summary. The acceleration is small, constant, and unexplained. Whether it is natural or artificial, it teaches us the same lesson, that we still do not understand how some matter moves between stars. Outside the equations, a subtler meaning took shape. Maybe this wasn't propulsion in the human sense. Maybe it was response, a material memory reacting to light after billions of years of exposure, a fossil of motion preserved across time. Imagine an object forged in another system, its minerals aligned in a magnetic field long vanished. Now, under our sun, those same atoms awaken, repelling or absorbing radiation, unevenly creating a drift that mimics intention. The cosmos itself becomes the engine. To an observer, the result is indistinguishable from choice. A rock moves where it shouldn't and we assign it will. But perhaps it is simply obeying laws we have yet to write. By mid-November, the deviation stabilized freezing Atlas into a slightly altered path that would carry it past Mars and back toward the outer dark. The acceleration ceased as suddenly as it began, like a breath released. No one could say whether the effect was over or merely paused. If the mechanism was internal, it might reignite when sunlight struck a new angle months later. If it was something else, something guided, then perhaps the course correction was complete. The final data release read with bureaucratic restraint: observed deviation consistent with sustained non-gravitational acceleration. Mechanism undetermined. Yet behind that sentence was wonder. A silent traveller had shrugged off gravity's chain and rewritten its own orbit. It reminded every scientist watching that even the most elegant equations are still only guesses. In a universe measured by attraction and pull, 3 Atlas moved as if remembering freedom, a fragment of some forgotten order gliding through sunlight with the quiet confidence of something that refuses to fall. When 3 Atlas reached the far side of the sun, telescopes expected to see it fade, its heat dispersing its brightness, falling into ordinary silence. Instead, what appeared was something no cometry model could easily contain: a labyrinth of jets moving not as chaos but as geometry. From the Very Large Telescope in Chile, high-resolution imaging revealed at least 5 active outflows, each pointing in a different direction. One streamed along the orbital path, another angled sharply north, and one against all expectation pointed directly toward the sun. That single jet rewrote the rules. Cometry physics dictates that solar radiation pressure pushes all material away from the sun. It is the reason every comet grows a luminous tail pointing outward. Yet here was Atlas releasing matter in the opposite direction, matter that seemed to resist that radiation rather than flee from it. The data was clean. Spectral maps confirmed a persistent sunward jet steady over several days, its brightness oscillating with the object's slow rotation. It wasn't an illusion, nor an observational artifact. Something in the comet's structure was pushing back. Scientists searched for a natural explanation. One idea suggested day-night asymmetry. Perhaps the jet came from the shaded side where trapped gas escaped through deep fissures and erupted along a path that happened to aim toward the sun. But that still failed to explain the stability. The jet held its alignment for nearly a week, far too long for random venting. Another theory proposed electrostatic repulsion. A solar wind charged the comet's surface. Particles might have been ejected along magnetic field lines that curved back toward the star. A neat concept, yet the required charge density was astronomically high, far beyond anything measured. That left the uncomfortable possibility that the direction was intentional, or at least regulated. If internal channels directed the gas flow through hardened conduits beneath the crust, the result could be a collimated stream capable of overcoming weak solar pressure. Such systems exist naturally on smaller scales in cryovolcanism, where heat and pressure focus into narrow vents producing symmetrical plumes. But Atlas's pattern was too perfect, too rhythmic, almost engineered by its own mineral logic. At the same time, another mystery emerged. Observers noticed a dramatic colour shift. Before perihelion Atlas glowed a dull reddish hue typical of dust-rich comets. Afterward, its tone changed to a deep metallic blue, a transition recorded across multiple instruments. The shift was not gradual, it happened within days. In astronomy, colour reveals chemistry. Red means dust and organic carbon. Blue means reflected light from smaller particles or emission from excited gas. But the sudden dominance of blue defied both trends. One possibility, Rayleigh's scattering light scattering through ultrafine particles smaller than a micron producing blue wavelengths. That would imply the object was shedding dust grains far smaller than expected, perhaps the residue of a vaporized crust. Another molecular emission, cyanogen Cn and diatomic carbon C2 can glow blue-green when sunlight excites them. Yet their spectral fingerprints were weak, almost absent. So what caused the shift? A joint team from NASA's Infrared Telescope Facility and ESA's Rosetta Archive Group compared the reflectance data with known cometry spectra. They found something extraordinary. The pattern matched not carbon dust, but nickel-rich silicates minerals that reflect blue light under intense solar heating. Nickel. Again. It was the same element already noted in earlier analyses of the object's unusual density and spectral absorption lines. If true, the blue glow might not be gas at all, but metallic reflection. the exposed skin of a nickel-bearing surface reacting to solar radiation. That idea changed everything. It meant that beneath its dusty outer shell, Thrusius Atlas could have a core made of heavy elements rarely seen in comets, materials more typical of planetary interiors or manufactured alloys. The speculation spread quickly, then quietly. Was it possible that this interstellar traveller wasn't a chunk of primitive ice, but a fragment of something far older forged in the heart of a destroyed world, or built for purposes long forgotten? The idea was uncomfortable even to those who entertained it. No one wanted to say artificial, but everyone felt it hovering behind the data, a presence as persistent as the sunward jet itself. For now, the working consensus was restrained. Observed colour change consistent with thermal alteration or exposure of reflective subsurface material. A neutral line in a paper that concealed deep unease. When the light curve models were overlaid, a rhythm appeared, brightness rising and falling, with rotation synchronized with the shifting hues. Every turn of Atlas revealed another facet, another glint of metallic blue. To the eye it was beautiful, to physics it was unsettling. How could something so small and ancient carry such order? How could a body of dust and ice shine like polished metal under the sun? Maybe, as one astronomer wrote in his notes, it's not resisting the sun, it's remembering it. Perhaps that was true. Perhaps the strange sunward jet and the sudden blue light were not defiance but memory, the echo of an origin in a place where the laws of heat and pressure once shaped it differently. Or perhaps we were simply witnessing how the universe expresses precision without purpose. In either case, the sight of that cold blue traveller reminded us that even the simplest laws of light can still surprise us, that colour like gravity sometimes bends toward mystery. In science, silence is supposed to mean certainty, data under review analysis, in progress conclusions forming carefully. But in the case of 3I, Atlas, the silence began to sound like avoidance. Weeks after the object's encounter with the Sun, researchers expected a full data release. Instead, what arrived were fragments, summaries, partial tables, missing images. The official explanations were ordinary calibration delays, cross-checking, data compression, and yet behind closed conferences whispers began. What exactly are they not showing us? The first to speak publicly was Dr. Michio Kaku. In an interview, he accused NASA of unnecessary secrecy, saying, "If this object is just a comet, why hide the images if it isn't? Why pretend everything is normal?" It was a sharp question wrapped in calm, and it struck a nerve. For decades, the world's space agencies have shared comet data freely. From Hale-Bopp to 67P Churyumov-Gerasimenko, every image, every spectrum, every anomaly had been made public within days. But with Atlas high-resolution images from the Mars Reconnaissance Orbiter MRO captured on October 2nd and 3rd were delayed for more than 3 weeks. When they finally appeared, they were cropped, compressed, and quietly filed without announcement. What they showed, or what they didn't, became the centre of debate. Insiders described the raw images as visually unusual. Unconfirmed leaks mentioned sharp surface contrasts, almost architectural shadows inconsistent with the smooth contours of known comets. Others dismissed it as overexposure, a trick of light artifacts of digital correction. But the timing was strange. In the same week the data was withheld, Congresswoman Anna Paulina Luna sent a formal request to NASA demanding the release of all Mars-based imagery related to Atlas. Her statement cited possible irregularities in the data pipeline and unexplained delays inconsistent with standard planetary imaging schedules. A few days later, a second request followed, this time asking for telemetry from Perseverance, the rover on Mars, which had reported unusual activity in the upper atmosphere on October 5th. Officially, the rover was never looking at Atlas. Unofficially, it was in the right position to detect its light. What was this unusual activity? The public reports remain blank. To be clear, most scientists don't believe in conspiracies. Data takes time. Instruments fail. But the pattern was undeniable. Too many delays, too many missing frames, too much caution for something labelled a standard interstellar comet. In internal memos later leaked to journalists, one line stood out: certain imagery may require contextual analysis prior to release. Contextual analysis, a phrase that said everything and nothing. What kind of context does an image of a rock need? Some speculated that the delay came from data saturation, that the raw files contained optical flares or pixel noise that looked like artificial geometry. Others whispered of signal contamination, Perhaps the radio instruments picked up reflections or interference from the object itself. Whatever the reason, the effect was the same. The public narrative slowed, the mystery grew, and 3 sus Atlas drifted deeper into secrecy. Even now, fragments of those missing images surface, occasionally blurry reproductions adjusted for contrast shared by anonymous technicians. In one, the object appears almost facetted, as if its surface were divided by panels of different reflectivity. In another, the sunward jet glows with a uniform blue hue, not the irregular pattern of dust or gas. Each pixel becomes an argument. NASA has neither confirmed nor denied their authenticity. Instead, their statements remain procedural. Images are being processed for scientific accuracy and will be released once validated. Weeks turned to months. The validation never came. Transparency, once a cornerstone of space science, began to feel conditional. Some defended the caution. The data must be right before it's public, they said. Others countered that the delay itself distorts truth, creating suspicion where none may exist. Between those two positions lies the uncomfortable core of modern science, the balance between certainty and openness. Perhaps what's being hidden isn't revelation but confusion. Perhaps even the experts don't yet understand what they're seeing. In one closed symposium, a senior astronomer reportedly said, "If the images show what I think they do, we will need a new vocabulary." That sentence never appeared in the official transcript. Outside the scientific world, the story evolved on its own: documentaries, interviews, conspiracy threads. Some claimed Atlas was an ancient probe, others said it was a natural object misread by overzealous minds. In truth, the only mystery greater than the object itself was how little anyone seemed willing to say about it. And so between speculation and silence, 3 Atlas became something rare, not just a question of physics, but a question of trust. When data disappears, meaning multiplies. When silence replaces explanation, imagination fills the vacuum. And somewhere in that gap between what we know and what we're allowed to see, wonder begins to sound like warning. Maybe nothing was hidden at all. Maybe the real secret is that we still don't know what to believe. By the time the debate over missing data began to fade, another revelation was quietly emerging, one buried not in secrecy, but in the numbers themselves. Spectral analysis of 3I, Atlas, suggested something extraordinary. This traveller from the void was older than the solar system. The isotopic ratios of oxygen and carbon were incompatible with any known bodies born under our sun. Their chemical fingerprints, measured by infrared spectrometry and cross-verified by ALMA, pointed to formation in a star system at least 7 billion years old. Older than Earth, older than the planets that now observed it. That single number changed everything. If true, it meant Atlas was not merely a visitor, but a relic, a survivor of a long-dead star carrying within its atoms a record of conditions that predate our cosmic neighbourhood. Its structure, its orbit, even its stubborn resilience might all trace back to that forgotten place. But where could it have come from? Models of galactic motion suggest that over billions of years, stellar systems drift, collide, and dissolve into one another like waves crossing an ocean. A fragment ejected from one such system could wander interstellar space indefinitely frozen, bombarded by cosmic rays, altered molecule by time itself. Yet 3I, Atlas, did not look eroded or ancient. It looked preserved, as though it had been shielded, protected, or maintained. When the surface composition was reconstructed from the spectra, another surprise surfaced: a nickel-to-iron ratio several times higher than that of typical comets. Nickel, a metal that resists corrosion, that forms alloys used in spacecraft and turbines, not the brittle ices and silicates that define natural comets. Some scientists immediately suggested a plausible origin. Perhaps Atlas was a fragment of a planet's metallic core torn apart when its parent world collided with another during the violent youth of its star. If so, its composition would explain its resilience, a shard of a world's heart refined by pressure and time. But even that scenario failed to account for the balance of elements. The object's reflectivity, magnetic response, and heat retention suggested an engineered alloy, a mixture not typically found in planetary formation models. Of course, no one dared publish that conclusion outright. In scientific language, they called it non-standard metallic enrichment. In private, they called it impossible. If this object had indeed travelled for 7 billion years, enduring collisions, cosmic radiation, and temperatures near absolute zero, then what preserved its internal symmetry? Why did its surface reflect light, like polished mineral, not like fractured stone? A few proposed that Atlas could be the remnant of a technological civilization, not an intact machine but debris. A piece of something larger, once functional, now eroded into myth. A drift of interstellar wreckage mistaken for ice and dust. That idea, while electrifying, faced the same problem as all bold ideas proof. The data offered none, only suggestion pattern and unease. Still, the coincidence was haunting. The unusual composition matched no known class of natural objects. The metallic core model explained much, but not everything. Its reflective spectrum mirrored nickel-iron composites similar to those used in engineered materials on Earth. Its thermal stability exceeded the limits of porous rock, and its magnetic response behaved not like a random mass, but like an organized field. Could these be natural consequences of an alien environment or remnants of design so ancient it now behaved like geology? To answer that, we would need to know the system it came from, but the galaxy had long erased that trail. All we could trace was a faint corridor in space, its trajectory back toward a region 9 degrees from where the WOW signal was recorded in 1977. Coincidence, most said. And yet the mind resists coincidence when patterns begin to repeat. If Atlas came from that corridor, it would mean it had been drifting across the Milky Way for eons, perhaps guided by chance, perhaps by purpose. What kind of civilization could send a fragment across such distances, or what kind of cosmic accident could forge an object so precise that it looks like intention? Even if purely natural, its existence was still a kind of message. A proof that materials can survive longer than worlds, that memory can exist without mind. Imagine a piece of a dead star system still glimmering under another sun, whispering through the void in frequencies we barely understand. It doesn't need to be a ship to carry meaning. Its meaning is survival itself. One astronomer wrote in his notes, "Maybe 3 Atlas isn't a messenger. Maybe it's a fossil, the memory of an attempt that outlasted its makers." There is something humbling in that thought. In a universe that forgets everything, planets, species, even stars, here drifts a small, silent remnant that remembers. Its metals forged in another dawn, its surface burned by alien suns, its story written in isotopes rather than language. Perhaps that is the true secret of Atlas, not that it hides technology, but that it is technology the kind that nature and time create together. As it continues outward, now past Mars, into the cold, where sunlight fades and silence deepens again, it carries no answers. Only the quiet endurance of matter older than Earth, older than memory, proof that in the vast machinery of the cosmos, survival itself can be an act of design. It began as a faint coincidence, the kind that scientists are trained to ignore. But in cosmic investigation, sometimes a coincidence is all we have. When the first orbital projections of 3I's Atlas were compared against deep space radio archives, a subtle pattern appeared. Its inbound trajectory, the narrow corridor of interstellar space it had crossed before entering the solar system, pointed to a region strikingly close to the coordinates of the WOW signal. The mysterious narrowband radio burst recorded in 1977 at the Big Ear Observatory in Ohio. The alignment was not exact, but close enough to raise eyebrows, a difference of only 9 degrees. For decades, the WOW signal has remained one of astronomy's great enigmas, a sharp, singular spike at 1420 MHz, lasting just 72 seconds, never to repeat. It was the frequency of neutral hydrogen, the most universal element in the cosmos, and for that reason long considered the logical channel for any civilization wishing to announce its presence. Now, nearly half a century later, another anomaly had appeared, one also centered near hydrogen frequencies, also transient, also unexplained. Atlas's post-perihelion radio emissions detected at 1.6 as 65 and 1. 667 GHz fell within the same electromagnetic family. Hydrogen and hydroxyl, the two ends of the cosmic water molecule H2O. It could be coincidence. But coincidences this elegant tend to make scientists uneasy. Dr. Avi Loeb ran the numbers. He calculated the probability that two independent phenomena separated by nearly 50 years would align both spatially and spectrally by chance. The odds were small, 1 in 10,000. Not impossible, but enough to warrant a pause. What made the link even more intriguing was the behavioural symmetry. Both events were sudden, short-lived and non-repeating. Both occurred at frequencies tied to the chemistry of life. And both came from directions with no known pulsars, quasars or repeating astrophysical sources. For the first time, serious researchers began to whisper the question they'd avoided for decades. What if the WOW Signal wasn't random noise, but a point of origin. Could 3A up Atlas be a fragment from the same region, or in the more daring versions from the same source that sent that long-lost transmission? Skeptics moved quickly to ground the discussion. Hydrogen frequencies are common throughout the galaxy, they argued. Any alignment could be coincidence, any signal a product of reflection, any mystery an illusion of human pattern seeking. And yet even skeptics could not ignore the alignment. When the Harvard-Smithsonian Center for Astrophysics reprocessed the old 1977 data with modern algorithms' faint sidebands, appeared fluctuations around the main hydrogen line matching the offset frequencies of hydroxyl. It was not proof, but it was enough to reopen the conversation. Could the two phenomena, separated by time but connected by spectrum, represent two halves of a single message, hydrogen plus hydroxyl, the formula for water, the universal solvent of life? If intentional, it was elegant beyond words. If natural, it was coincidence raised to poetry. The thought that perhaps we were not looking at a comet but at a messenger, or at least a relic from the same cosmic neighbourhood that once whispered "wow" across the void unsettled even the most disciplined minds. In closed meetings, researchers debated whether to even mention the correlation publicly. To connect Atlas with the wow signal was to step into the realm of speculation. But the numbers were persuasive, and curiosity has always been stronger than caution. Some proposed an intermediate theory resonant coincidence. Maybe both phenomena stem from natural hydrogen resonance in dense interstellar clouds, a kind of cosmic echo chamber that amplifies specific frequencies. Atlas, passing through that region eons ago, could have inherited isotopic patterns from it, explaining both its radio signature and its unusual chemistry. In that sense, it was not the sender of a message, but a souvenir of the place where the message originated. Others leaned further into metaphor. If the wow signal was a hello, perhaps Atlas was the footprint, the physical trace of a civilization that once called out, now reduced to silence and motion. No one could prove it, of course, but the symmetry between hydrogen's voice and Atlas's glow haunted everyone who studied it. In an essay published quietly in Astrophysical Letters, Loeb concluded, "Whether the similarity is physical or symbolic, it demands humility. Two events separated by half a century may together represent a single phenomenon we do not yet have the language to describe, and perhaps that is the lesson hidden beneath the data. The universe rarely repeats itself, but when it does, it may be whispering a pattern we have yet to recognize. The trajectory of Atlas and the direction of the wow signal cross only briefly in the map of the galaxy, a fleeting overlap in the great dance of matter and meaning. But to those who have traced both paths, it feels less like coincidence and more like conversation. Maybe the signal and the object share nothing at all but timing and chemistry. Or maybe across billions of years and light years they are two syllables of the same cosmic sentence, one written in radio, the other in light. And as always, the universe leaves us to wonder whether it was speaking to us, or simply reminding us to listen. When the last datasets were compiled and the final orbit confirmed 3I, Atlas was already fading from sight, a quiet ember retreating into the cold beyond Mars. Its story, however, refused to fade. Across observatories and institutions from Cambridge to Tokyo, one conclusion began to crystallize: whatever 3I Atlas was, it did not fit the model. Not for a comet, not for an asteroid, not for any known fragment of cosmic debris. It was an anomaly, a reminder that the universe still holds more exceptions than rules. In the sterile clarity of equations, we like to think we understand how matter behaves, how light scatters, how dust sublimates, how orbits bend. But then something arrives from the dark and behaves otherwise. It follows no pattern, obeys no comfort. It teaches us through its defiance that our laws are only temporary agreements with nature, valid until the next stranger passes by. Atlas has given science more questions than answers, a structure that breathes without tail, an acceleration without thrust, a signal without repetition, a colour without chemistry, and a silence that feels deliberate. Each of these puzzles may yet find an explanation in physics, in probability, or in our own tendency to see meaning where there is only complexity. But until we admit what we do not know, discovery remains impossible. The object's passage forced astronomers to confront an uncomfortable duality, that skepticism and imagination are not opposites but partners. To observe a mystery without declaring it miraculous, to speculate without surrendering reason, that is the true discipline of science. We can calculate trajectories with perfection, but curiosity still demands humility. Every time we claim certainty, the cosmos offers correction. When asked about the meaning of 3I, Atlas, Avi Loeb summarized it with disarming simplicity: either it is a new kind of natural body, or we have witnessed the remains of something once made. In both cases, our understanding of the universe must expand. That statement captured the spirit of this moment, a rare intersection of data and wonder. For if Atlas is natural, then nature has learned to imitate purpose. If it is not, then purpose has endured long enough to become nature. Either way, the distinction begins to blur. Throughout history, every leap in science began not with confidence, but with confusion. The heliocentric model began as heresy. Quantum mechanics began as contradiction. Even the theory of relativity was born from a failure to explain a small, stubborn anomaly. Perhaps Atlas is another such anomaly, a quiet herald of physics yet to be written. The lesson it leaves us is not to believe in aliens or miracles, but to believe in the unknown. To treat each anomaly not as threat, but as invitation. To let data speak before dogma translates it. Because what if the next visitor arrives, and we are too certain to notice what it means? Transparency, open data, and cross-disciplinary dialogue are not luxuries. They are necessities for a universe that refuses to fit our models. When information is withheld, even for caution, speculation fills the void. When science closes its doors, mystery becomes myth. And myths once born are hard to silence. That is why the true legacy of 3I Atlas may not lie in what it was, but in what it taught us about ourselves, our need for control, our fear of error, and our fragile balance between wonder and proof. If the cosmos could speak, perhaps it would tell us, "Do not rush to define me. Watch longer, listen better, doubt more gently." Maybe the object was nothing more than a comet made strange by coincidence and angle. Or maybe it was something greater, a fragment of memory, a shard of intention, a message written not in words but in endurance. Whatever it was, it came, it glowed, and it left quietly rewriting our sense of what might drift between the stars. And in its wake, it leaves a single commandment for every scientist, every dreamer, every listener who looks into the dark: stay curious, stay honest, and never mistake silence for absence. On November 9th, 3I Atlas once again shook the sky. It continued to graze the sun, releasing an extreme surge of heat, as if challenging the very source of light that sustains the universe. 3I Atlas had passed perihelion many times before, but this time it flared 5 times brighter without losing even a single grain of dust or trace of vapor. A comet that shines without losing mass, a motion so gentle, yet defying every law of gravity. All instruments recorded the same undeniable truth: it was accelerating, but no natural law could explain how. The deeper the analysis went, the clearer the contradictions became. Nickel surpassing iron, an orbit of absolute precision, light bending in the wrong direction. Every detail, every number, whispering of an object not born of nature, but created with intention. The repeated collisions of 3I Atlas with the sun left scientists in silence. Could something be about to happen to the universe itself? Let us continue to uncover the mystery of 3I Atlas in its most recent encounter with the sun. Because perhaps this story does more than challenge humanity's understanding of the cosmos. It asks a question no one dares to answer. Are we truly alone in the endless expanse of space? The light of 3 Atlas once again swept across observatories, satellites, and the patient lenses of telescopes watching the sky. And when it reached its perihelion, the closest point to the sun, the impossible happened. The comet brightened, not slightly but 5-fold. For astronomers, that number was not just a detail, it was a scream. A comet cannot do that without burning away a part of itself, without shedding vast clouds of vapor and dust that burst like a veil into the sunlight. Yet none of that appeared. No grand coma, no blazing tail. The light came, but the debris did not. It was as if the object had learned how to shine, without losing itself. Across observatories, the data synchronized. Spectrographs confirmed the rise in magnitude, the lack of thermal emission. Everything pointed toward a contradiction. If the brightening were natural, it would demand a loss of at least 13% of the comet's total mass. That is not a poetic number, it is an unavoidable one. It emerges from the balance between radiation surface area and escape velocity, a law of evaporation written in the fabric of thermodynamics. But the universe that morning chose not to obey its own law. So scientists found themselves at a crossroads. Either a massive cloud had somehow escaped every instrument, or the acceleration the strange push detected in its orbit came from something that did not behave like sublimating ice. In the months before, perihelion, 3I Atlas had moved as every rock should. 4,022 separate measurements from 227 observatories drew a perfect gravitational curve. Every line fit Newton, every vector obeyed the sun. But after the close pass, the math broke. A non-gravitational acceleration appeared, tiny but measurable, a push invisible, consistent as if some small engine had awoken correcting its path. Astronomers called it an anomaly, the public called it impossible, and somewhere between those two words lay a quiet truth: something had changed. If it were just ice, the gas should have burst unevenly, chaotically, a spray of random vents, spinning the nucleus like a wounded stone. Instead, the thrust of 3I Atlas aligned perfectly within the orbital plane. No vertical component, no erratic tumbling, just a clean, deliberate vector aimed outward from the sun. It was this precision that haunted Avi Loeb, a theorist from Harvard, known for his habit of asking forbidden questions. He calculated that if the observed acceleration came from natural outgassing, then a vast fraction of the comet's mass must have vanished, and yet the object remained intact. He wrote simply, "Either the mass loss is invisible or the force is not sublimation. What could it be then? A reaction to sunlight through a material we've never seen, a pressure field emerging from an exotic compound, or a controlled thrust and intentional correction in trajectory? If the latter were true, something had switched on. Imagine that moment, a silent traveller after untold eons adrift between stars passing near our sun for the first time. Its surface dark, metallic, scarred by radiation, now ignited not by fire but by command. A single pulse of acceleration so slight it would escape every human sense, yet enough to announce that it was awake. No one saw a flame, no one heard a signal. But the math itself whispered motion without cause. In cosmic investigation, that is the equivalent of a voice in an empty room. The notion, of course, is extraordinary. Science does not yield to imagination easily. It demands proof, repetition, prediction. But sometimes the data opens a door that reason hesitates to walk through, and beyond that door lies the vast unknown where our instruments end and curiosity begins. If 3I Atlas truly exerted its own force, then it belongs to a class of motion we have never catalogued. Not ion propulsion, not radiation recoil. Something subtler, an internal reconfiguration, perhaps a shift of mass within producing a net vector change. In physics that would require an intentional structure. A body capable of balancing internal stresses, conserving angular momentum, and responding to external energy. That is by definition a design. Yet even to think it feels like crossing a boundary. To suggest purpose where we expect only accident is to challenge the humility science teaches. Still, humility cannot silence the question itself. For a time, researchers resisted the idea. They recalculated trajectories, adjusted albedo coefficients, modified thermal models. Perhaps the comet's surface was unusually dark, absorbing heat differently. Perhaps there were hidden vents on the sunward side, invisible to our telescopes. Each explanation brought a sigh of relief and another inconsistency, because no model, no matter how elegant, reproduced the data entirely. The acceleration remained, the brightening refused to fade, and the surface polarization negative extreme violated the scattering laws known from any cometary dust. The numbers were not wrong, they were simply uninvited. One could imagine 3I Atlas as a mirror held up by the cosmos itself, reflecting not our light but our limits. For centuries, humanity has named the anomalies it could not explain fireballs, mistaken for gods, auroras, mistaken for spirits, pulsars, mistaken for aliens. Each time the unknown shrank before the discipline of understanding. But now, in this age of precision, when every photon is measured, every orbit traced to decimals, the cosmos has found a new way to test us by offering us something that behaves correctly in all ways, except the ones that matter most. There is a peculiar beauty in contradiction. It is the birthplace of every theory, every rebellion of thought. When a comet brightens without burning, when motion emerges without cause, the universe is inviting us to look closer not with belief, but with wonder. And perhaps as the mathematicians debated and the telescopes adjusted, something else was happening. Perhaps this was less a discovery than a reminder that the cosmos is not a machine we have mastered, but a conversation we have barely begun. Somewhere across the quiet expanse, a traveller moved on, silent, constant, unchanged. No one knows whether it will return, but in its wake it left a question so vast that even the stars seemed to pause before answering. After the first shock of that impossible brightening came the second, quieter revelation. A change in motion so small it would never touch the naked eye, yet so precise it broke the harmony of Newton's equations. For months before, perihelion, 3i Atlas, obeyed gravity with obedient grace. Its orbit was predictable, its parameters pure. But once it curved around the sun, the numbers began to drift, not chaotically, not like a natural jet of gas, but with intent. The instruments at Mauna Kea and Paranal caught it first a subtle deviation, a curve ever so slightly shallower than expected. When plotted across 4,000 data points, the offset became undeniable. Something was pushing the comet away from the sun with an acceleration roughly 1,000th of Earth's gravity. In human terms, that is the pressure of a feather, yet in celestial mechanics it is thunder. Normally such a drift would be blamed on outgassing. As frozen volatiles sublimate, they act like natural thrusters, throwing vapour into space and nudging the nucleus forward. But this time the direction was too clean. The vector lay perfectly within the orbital plane, its angle to the sun constant through each measurement window. No wobble, no torque, no random spin. That alignment suggested something far more deliberate, a thrust governed by geometry, not chaos. Avi Loeb's models gave the paradox a voice. If the push came from sublimation, then the comet should have lost more than 13% of its mass. Its albedo should have dropped, its surface should have vented plumes of vapour bright enough to stain the spectrum. Yet no plume appeared. The mass was still there. The brightness somehow was still rising. Either our telescopes had collectively missed a vast exhalation of gas, or the force had another origin entirely. In lectures and late-night panels, scientists debated the possibilities. Some invoked exotic ices, super volatiles that vaporize at temperatures close to absolute zero. Others imagined microfractures on the surface releasing bursts of heat in timed sequence. But every new model required one more coincidence, one more unprovable assumption. The further they reached, the more the data resisted. So Loeb framed the puzzle differently. What if 3i Atlas did not react to the sun, but responded to it? What if the energy was absorbed, converted, redirected? A radiation pressure sail made of layered nickel compounds could in theory produce such a steady acceleration. The ratios of nickel to iron observed by spectroscopy seemed inconveniently to fit that profile. No one dared call it artificial, not yet, but the equations left the door ajar. Even within that hypothesis, the mind rebels. To imagine a structure capable of steering itself is to cross from observation into intent. Yet every field has its moments when numbers whisper of something beyond habit. When Voyager 2 left the heliopause, it carried our questions into silence. Perhaps 3i Atlas carried silence back. At the observatories, technicians described the motion as too smooth. There were no micro-jumps, no thermal oscillations, no trace of rotational decay. One analyst compared it to a satellite performing a gravity assist with full course correction. Another wrote in the margin of a report, "If this is outgassing, it's the most disciplined gas I've ever met. Still, science must breathe through skepticism. The data could be incomplete, the sensors could have drifted, the comet could have masked its venting behind its own shadow. All were valid, all were possible. Yet somewhere under those measured disclaimers an unease began to take root. The feeling that the universe was showing us not an error, but an instruction. For if a rock can steer, if a comet can alter its path with precision, then the boundary between the inert and the intentional has already been crossed. That single truth, delicate as the acceleration itself, hung in the air of every observatory. And while no one said it aloud, each scientist who ran the numbers again felt it the same way, a quiet, inexorable realization that we might be watching a traveller, not a relic. There is a moment hidden within the silence of mathematics when motion becomes intent. For 3i Atlas, that moment came not in a burst of light, but in the smallest deviation imaginable, a subtle, graceful defiance of gravity's command. In the raw data, it appeared as a shift of decimals, a curve fractionally shallower than Newton would allow. But in the language of physics, that curve meant one thing: something had awakened. For months leading up to its perihelion, 3i Atlas moved like a perfect equation, each positional reading from more than 200 observatories aligned within the precision limits of the models. It was a silent, obedient body until the instant it wasn't. After it swung around the Sun, its orbit no longer matched predictions. The deviation was small, 1 part in 10 million, but it grew consistently with every measurement. It was as if an invisible hand had reached out and adjusted its path by design. Scientists called this change a non-gravitational acceleration, a phrase that describes the phenomenon while politely ignoring its cause. To an ordinary comet, such an effect would come from jets of vapor, unevenly erupting from the sunlit face. But every analysis of 3i Atlas showed a vector too disciplined, too stable. The direction of thrust aligned precisely with its orbital plane, a plane shared by the major planets. It was an alignment so perfect it defied the chaos of nature. Avi Loeb once wrote that nature, when left to itself, produces elegance but not precision. Precision implies decision. That thought lingered over every discussion, unspoken yet unavoidable. The acceleration seemed to switch on after the comet reached perihelion, as though responding to the sun's energy not by reaction, but by recognition. There were whispers among the research teams. What if 3i Atlas had waited? What if it had been dormant, conserving energy across light years, and the proximity to our star served as its signal to awaken? The hypothesis was dismissed publicly, but privately no one could fully erase it. The data had the rhythm of command activation, followed by control, followed by retreat. In the recordings from the European Southern Observatory, a slight phase change appeared in the reflected spectrum, like a shimmer that lasted less than 2 hours. It wasn't enough to be called emission, but it was something, a change in reflectivity that hinted at movement beneath the surface. Perhaps it rotated a shield, redirected panels, adjusted orientation. These are mechanical interpretations, but they fit the numbers far more elegantly than random venting. Imagine this through the calm of cosmic silence, an object older than history, its body forged in alien light, crossing the solar plane for the first time. It absorbs radiation, translates it into a motion so subtle that only mathematics can see it. Then, with one quiet pulse, it shifts its path, not to escape, not to hide, but simply to continue. The act itself carries no sound, no signal, no declaration. Only the numbers tell the story, and they speak of control. If that control exists, it implies awareness, or at least architecture. To build something that can awaken after eons demands an understanding of durability beyond any human engineering. A system must withstand dust impacts, cosmic rays, micrometeor collisions, and yet still respond to sunlight as if obeying a stored command. It would need layers of protection, memory, and function, a vessel designed not merely to travel, but to wait. The thought is difficult to hold without drifting into wonder. Could there exist civilizations so ancient that their technology has outlived their creators, machines travelling endlessly, carrying no message but endurance itself? The cosmos could be full of them, silent and inert, until gravity and sunlight awaken them for brief moments of movement. We might not be seeing intent at all, only the echo of a design that persists beyond time, and still the image is hard to resist. A traveller reaching perihelion, its senses, warming its systems, remembering. No flames, no noise, just motion, resuming deliberate and exact. A machine performing its task, whatever that may be, without audience or command. After perihelion, 3i Atlas continued on its altered trajectory, fading back into darkness. The acceleration persisted for weeks, steady and calm before slowly diminishing. Some said the force ceased once it had adjusted to its course, as though it had completed whatever correction it needed. Others said the loss of thrust was proof of an internal failure, a dying system spending the last of its stored energy. Both theories fit, and neither explained everything. When the final observation came in, the comet's light was faint, its spectrum nearly featureless. But for those who had watched its brief defiance, that faintness felt more like withdrawal than decay. The data told a story not of chaos but of purpose, restrained, minimal, efficient, and in that efficiency scientists saw the most human of patterns choice. Perhaps that is why 3i Atlas captured imagination more deeply than any other comet. It reminded us that even silence can carry meaning, that precision itself may be a language, and that not all awakenings come with noise or flame. Sometimes the universe stirs softly, and in that subtle motion, it whispers the most profound question of all: who or what still remembers to move? When the first phase of analysis concluded, the astronomers did not speak of mystery. They spoke of geometry. They spoke of the way 3i Atlas moved not like a fragment of ice set adrift, but like a body aware of its own direction. The more data they plotted, the clearer the shape became a vector born from order, not randomness. Across hundreds of observation logs, one pattern held constant. The non-gravitational acceleration pointed directly away from the Sun, hugging the orbital plane with uncanny precision. Not a fraction of a degree above or below, not the slightest hint of torque or roll. The thrust behaved as though it had been programmed to align with the Sun itself, a clean mathematical choreography. To understand why that alignment matters, one must recall what chaos looks like. Natural comets vent gas from irregular surfaces. As sunlight warms different regions, the pressure jets fire in unpredictable bursts, sending the nucleus tumbling. Each spin alters the jet's direction. Each jet alters the spin. It is a dance of imbalance, chaotic, temporary yet beautiful. But 3i Atlas refused to join that dance. The push it generated was steady, coherent, and silent. Instruments registered no flicker in its light curve, no indication of rotation instability. In dynamic simulations, its trajectory produced the same smooth arc that a guided craft would trace if it were correcting its path against gravitational drift. Every statistical test yielded the same conclusion: the odds of such consistency through random venting were nearly zero. Avi Loeb and his colleagues began to model the data through the language of vectors and control systems. The result resembled something engineers know well: vector thrust alignment. In this model, even a low-power propulsion source can achieve stability if it keeps the thrust vector locked to the plane of motion. The system corrects its own deviation over time, much like a satellite maintaining attitude during a maneuver. That idea that a comet might unconsciously mimic the logic of a spacecraft drew quiet fascination. No one wanted to say the word artificial, but the symmetry of the equations whispered it anyway. Some researchers proposed that the comet's surface might contain a reflective lattice, perhaps nickel or another high-albedo metal, forming microstructures that naturally direct radiation in one dominant orientation. It would be an extraordinary coincidence of material science, but at least it stayed within the bounds of nature. Others saw something else. If radiation pressure truly caused the acceleration, then the reflectivity had to be nearly perfect, smoother than any rock, cleaner than any dust. The surface would need to act like a sail, catching the solar photons and converting them into motion. It would mean that the object wasn't just surviving sunlight, it was using it. To test this, Loeb's group reconstructed the force profile. The thrust aligned within less than 1 degree of the Sun's radial vector, a precision too fine for chance. Over millions of kilometers, the deviation never wandered. Every observation reinforced the same conclusion: this was motion under guidance. Whether that guidance came from physics or from purpose was a question the data alone could not answer. Yet even as they argued, the beauty of the phenomenon began to sink in. There was something almost poetic in watching a fragment of the cosmos move with the confidence of design. The telescopes followed it night after night, tracing its path like a signature written across the void. Each data point became a heartbeat, faint, distant, but deliberate. If this was natural, it meant nature had found a new way to write symmetry. If it was not, then humanity had glimpsed the first act of an intelligence that does not announce itself, but expresses its presence through precision. Either way, the laws of motion, once thought complete, now felt like the opening lines of a larger conversation. In the quiet control rooms under the red glow of monitors, the astronomers kept plotting. They knew they were watching something that should not happen, yet it happened anyway. Each curve of the orbit told a story, gravity calling, and some unseen hand answering. The geometry of motion had become geometry of intent, and in that intent, written across the mathematics, was a question that no one dared to utter aloud, because once spoken, it would no longer be science but revelation. For centuries, astronomy has found comfort in chaos. It is the signature of nature's honesty. Comets in particular are creatures of disorder, their surfaces scarred by impact, their cores riddled with frozen fractures. As they approach the Sun, they awaken violently, exhaling vapor from fissures carved by ancient cold. The result is beautiful, unpredictable, and utterly untamable. No comet until 3i Atlas had ever shown restraint. Ordinary comets are inconsistent dancers. Their jets of gas erupt at random, spinning the nucleus like a coin on a table. The direction of their thrust changes minute by minute, driven by heat, by rotation, by luck. A typical comet behaves like an orchestra without a conductor sound. and fury arranged by accident. When the gas vents unevenly, it adds small jerks to the orbit minor deviations that fade as the outburst subsides. This chaos is not a flaw, it is the heartbeat of nature's entropy. But 3 Atlas did not follow that rhythm. Its behaviour was calm, deliberate, and to some deeply unsettling. The thrust vector remained steady for weeks, never swaying from its alignment with the Sun. The torque expected from random outgassing was absent. The spin rate remained constant within measurement error. Where other comets roared with thermal irregularity, 3I Atlas whispered with precision. The difference is not merely poetic, it is physical. Random jets produce oscillations in both speed and brightness. Yet the light curve of 3I Atlas was smooth, almost engineered. Every burst of brightness corresponded to a controlled increase in acceleration, like a system responding to input, not coincidence. It was as though the object knew how to balance itself against the solar wind. This contradiction sent theoreticians deep into revision. Some proposed a layered nucleus with concentric shells that released gas evenly across the surface, an improbable yet comforting scenario. Others invoked magnetized grains, suggesting that the comet's rotation might align with the interplanetary magnetic field stabilizing its outgassing. But the required alignment precision was absurd within a fraction of a degree across millions of kilometers. It was possible, yes. But probability and possibility are different languages. At the Harvard-Smithsonian Center for Astrophysics, a small team simulated thousands of comets under varying venting conditions. None reproduced 3I Atlas's stability. When they plotted the results, the difference was not subtle, it was a void. Nature offered chaos, the comet offered control. Between the two, the models broke down. It was then that the conversation shifted from why to how. If such control existed, it demanded a mechanism. Radiation pressure alone was too weak. Continuous venting would have caused measurable loss of mass. Some unknown process had to be converting energy into motion, a feedback system balancing thrust and orientation. It did not need to be sentient, it only needed to be built. The phrase self-regulating body appeared in one paper buried in a paragraph meant to be ignored. The author withdrew it in revision, fearing sensationalism, but the idea remained alive in discussion rooms. A self-regulating comet would be a new class of object, a structure that interacts with sunlight like a sail, not through reaction but through geometry. Its surface would have to consist of compounds that reflect and absorb light in selective ratios, creating thrust in one direction. It would act as both engine and stabilizer. In theory, such a body could exist not as an alien probe, but as a remnant of cosmic engineering, perhaps a byproduct of planetary debris refined by stellar radiation. Over eons, collisions and erosion could shape fragments into balanced, responsive forms. The idea blurred the boundary between natural formation and intelligent design. The universe, after all, is the oldest engineer of all. Still, the precision of 3I Atlas continued to trouble those who studied it most. A natural object can mimic design once, but not for months. And when the same measurements repeated acceleration, constant vector pure, the numbers themselves began to sound like intention. A quiet debate grew in the scientific community. Was this the universe showing us a new kind of order, or was it reminding us that order itself might be evidence of something greater? Every field meeting ended the same way, with silence. No one wanted to be the one to say it. Control in itself is not proof of purpose, but it is proof of potential. And somewhere between those two lies the question 3I Atlas left behind, a question that lives between science and faith, between the chaos we know and the control we fear to acknowledge. As it glided through the heliocentric void, its surface still gleaming faintly from perihelion light, the comet carried with it a paradox that would not fade a natural body that moved like a thought. And perhaps in that strange equilibrium, it revealed something essential, that control and chaos are not opposites but partners in the language of creation. Among all the patterns that defined 3I Atlas, none disturbed astronomers more than the light that moved the wrong way. When the first high-resolution images from the Hubble Space Telescope arrived in July, they revealed something small but unmistakable. A narrow jet of material, a faint thread of light extending toward the Sun. That detail might seem innocent to the untrained eye, a smudge against the brightness, but to those who know the physics of comets, it was a violation. Every comet's tail points away from the Sun. Always. That rule is carved into radiation pressure itself. Solar photons and charged particles push the dust and gas outward, sculpting the familiar arc that sweeps into the dark. The sun repels, it never attracts. And yet in those photographs, the jet of 3I Atlas reached back almost as if defying the light that had just awakened it. At first, the team thought it was an imaging artifact, a misalignment between exposures. But the feature appeared again, faint, steady, unchanged across multiple orbits of Hubble's sensors. The angle was not random. It was precise within 2 degrees of the sun's vector, a jet that pointed toward the light. To produce such a configuration naturally would require an improbable coincidence, a vent positioned perfectly on the shadowed hemisphere of the nucleus firing gas at high velocity, while the comet spun slowly enough to hold orientation. Thermal modelling showed that any normal rotation period would smear the jet into a blur. But this one remained sharp. The comet seemed to maintain its direction as though locked in place. The simplest answer that we were seeing a controlled exhaust hovered unspoken in every meeting. A vent that faced the sun could act like a steering thruster correcting orbit, while compensating for radiation pressure. The idea was too deliberate, too human. Yet the geometry was undeniable. If this were outgassing, it was a form of propulsion we had never observed before thrust against the sun, the very source of energy that powered it. It was as if the comet had turned the laws of reflection upside down, using light not to flee but to anchor itself. In theory, such an anomaly could result from the interaction of magnetized dust and plasma winds. A charged particle field might bend the direction of ejected material back toward the sun under rare conditions. But the magnetic intensity required would exceed the interplanetary average by several orders of magnitude. The solar wind is not that strong. The comet is not that conductive. And still the data persisted. One astronomer called it the most disciplined chaos ever recorded. Another said quietly, "If this is natural, it is nature pretending to think." The jet's spectral signature showed no sign of cyanide or carbon, the normal fingerprints of cometary gas. Instead, it bore faint traces of metal ions, nickel and sodium shimmering at wavelengths, more typical of vaporized alloys than ice. When modelled, the emission curve fit a profile closer to molten nickel dust, a kind of reflective plume that could under sunlight generate a photonic recoil force, a reflective jet, a jet made to shine. This observation linked back to the earlier puzzle of 3I Atlas's composition, its unusual nickel-to-iron ratio, its low water content, its polished reflectivity. If this was coincidence, it was one with too many parts. If it was a pattern, then the pattern had purpose. And yet science cannot survive on awe alone. The teams at ESA and NASA continued to test every natural scenario. One possibility remained the Yorp effect, a subtle torque caused by asymmetric heat emission. Over time, it can alter an asteroid's spin or tilt. Perhaps 3I Atlas was experiencing an extreme version of it, but to generate the observed thrust, the thermal gradient would need to be hundreds of times stronger than known physics allows. The comet's surface would have to act as a near-perfect mirror, redirecting sunlight with precision. In that moment, physics itself seemed to hesitate, because what they were seeing was not merely a body illuminated by the sun, it was a body interacting with light as if it understood it. In simulation, labs models tried to recreate the event. None succeeded. A natural comet could not maintain such consistency. A random vent would never sustain such symmetry. Slowly, reluctantly, the discussion turned to geometry again, to the possibility of a structure hidden beneath the dust guiding the motion. If such a structure existed, it could mean one of two things. Either we had discovered a form of natural organization far beyond what we thought possible matter-learning order through radiation, or we were witnessing a relic of something once engineered. No one dared say which was more extraordinary. And as the last images of the jet faded into the glare of the sun, the question lingered like an afterimage. What kind of traveller throws its light backward, not away from the star, but toward it, as if returning a signal? If motion had challenged physics, composition now began to challenge chemistry. When the spectral data of 3I Atlas was first decoded, what emerged seemed almost impossible. The elemental ratios were backward. The comet contained more nickel than iron. That single inversion may appear trivial to a lay observer, but to astronomers and metallurgists it was like finding ice that burns. Throughout the solar system, from meteorites to planets, the abundance of iron surpasses that of nickel. The ratio is a fingerprint of stellar evolution, the direct child of nuclear synthesis inside massive stars. During supernova collapse, iron forms in the last stages of fusion, while nickel decays into it over time. The pattern is so consistent that every rock, every asteroid, every speck of dust in the solar record carries the same signature ion, dominant nickel subordinate. But 3I Atlas broke that rule. Its spectral lines revealed a different origin story, one that should not exist. In its reflected light, the peaks at 341 and 358 nanometers burned stronger than iron's baseline, and when calibrated against known reference spectra, the numbers inverted. Nickel exceeded iron by almost a factor of 2. The chemistry of creation had been reversed. For days, researchers doubted the data. Perhaps the calibration was off, or solar contamination had distorted the readings. But repeated measurements from the Subaru telescope and the Lowell Observatory confirmed the result. Each new observation made the anomaly firmer, not weaker. The instruments were telling the truth. The universe apparently was not. Nickel in abundance is not a trivial matter. It is one of the most resilient metals in the periodic table, resistant to oxidation, tolerant of radiation, capable of maintaining structure under extreme heat. In industry, it is the cornerstone of alloys designed to survive plasma engines, reactor walls, and interplanetary re-entry. If nature had indeed produced a body dominated by nickel, it would have been forged in temperatures higher than most stars could sustain, or built by someone who understood why that metal must endure. There was something eerily deliberate about it. A body meant to cross interstellar space for millions of years would need to be both reflective and stable, resistant to corrosion, slow to decay. Nickel would serve that purpose perfectly. Its spectral albedo would protect it from constant bombardment, while its mechanical strength would preserve its shape against micrometeor impacts. The more scientists analysed the data, the more the material composition looked less like coincidence and more like selection. But speculation walks a fine line, and no scientist was willing to cross it openly. Instead, they invented new hypotheses, safer ones. Perhaps 3I Atlas was born in the furnace of a supernova remnant, where nickel was produced in overabundance before the heavier elements could form. Or perhaps it came from a binary system where repeated accretion stripped away lighter compounds, leaving only the metallic heart behind. These explanations soothed the fear of intent, but not the curiosity. As the models multiplied, one fact persisted: such ratios were statistically improbable. Out of tens of thousands of known comets and asteroids, none matched this inversion. Even the most exotic interstellar visitor before it, Oumuamua, had shown no such anomaly. Whatever 3I Atlas was made of, it came from a place unlike any known region of the Milky Way, or from a process that no one yet understood. In the silence of that realization, something subtle changed in tone among the researchers. The language of reports began to shift from object to structure, from body to composition. Even the cautious papers that rejected the idea of intelligence began to use phrases like engineered resilience or metallic uniformity. The data itself was pulling them toward a new vocabulary. There were moments late at night when the younger astronomers spoke more freely. They would sit in the dim control room surrounded by screens that shimmered with spectroscopic lines and whisper about the implications. Could a fragment of engineered matter drift across the galaxy long after its makers were gone? Could the laws of physics preserve artifacts the way geology preserves fossils? The thought was both comforting and terrifying that the cosmos might not be empty of creation, but full of its remains. Still, the official stance remained cautious. Every scientific sentence ended with the same quiet disclaimer: further observation required. Yet in private, the conviction was spreading that nickel had spoken where words could not, and that in the metallic shimmer of 3I Atlas lay the first trace of something crafted to last forever. When the chemical analysis of 3I Atlas deepened beyond metals, the picture grew even stranger. If the overabundance of nickel had rewritten the laws of formation, the next discovery erased what little remained of familiarity. The comet was almost dry. Typical comets, whether from the Oort cloud or the Kuiper belt, are half water by mass. Their luminous tails are born of ice sublimating into gas, a transformation so violent it can be seen from millions of kilometers away. In that vapor, the signature of cyanide CN has been the most faithful companion of cometary spectra since the first telescopes learned to dissect light. Cyanide is ubiquitous. It is the fingerprint of the early solar system, the molecular ghost of cosmic chemistry. But in 3I Atlas, cyanide was gone, vanished. Across dozens of observations, the cyanide emission lines, those fragile markers around 308 nanometers, were missing, replaced by a clean metallic silence. There was a faint trace of carbon monoxide, a whisper of sodium, but nothing resembling the organic richness of a normal comet. The ratio between nickel and cyanide, in fact, was higher than in any recorded celestial object. It was not the ratio of an ice body, it was the ratio of an artifact. At first, researchers assumed an instrumental fault. Perhaps the detectors had saturated under the glare of the sun, washing out the lines. But the absence was consistent across instruments. Hubble Subaru and the Very Large Telescope all agreed. The data held. 3I Atlas contained almost no volatile compounds. It was not a snowball, it was something else. What replaced water and cyanide was equally telling. The residual spectral features hinted at oxides of nickel and silicon materials that form not in the cold, but in heat. They are the compounds of fabrication, the skin of machines, the shell of engines. In engineering, nickel oxide resists corrosion, reflecting light and dispersing radiation. It endures. To find it in an interstellar object was to glimpse the possibility that endurance had been the goal all along. A few bold voices began to ask what if the dryness was intentional. A dry surface would never erupt, never fracture, never lose its mass to sublimation. It could cross countless systems without changing shape. Water for a vessel meant to travel the void is not a resource, it is a liability. To retain integrity, one must give up volatility. The comet's very sterility might have been its protection. In a closed discussion at the European Southern Observatory, one scientist described the composition as the signature of preservation, not evolution. Another compared it to a coating an exoskeleton made to survive stellar heat. Both remarks were struck from the final transcript, but in their removal they spoke louder. Still, the idea of design remained taboo. The more acceptable theory was that 3I Atlas came from an ancient radiation-baked region, near a dying star, a place where water and organics had long since boiled away. It could be the shard of a planet stripped to its metallic bones, wandering through the galaxy like the fossil of a world. That version comforted the community. It explained the anomaly without invoking intention. And yet, there were subtleties in the data that resisted even that explanation. The water content of 3I Atlas was not merely low, it was too precisely low, around 4% by mass, consistent across every measurement window. Natural bodies fluctuate, they vent unevenly, they lose mass over time. But 3I Atlas remained constant, as if its composition were regulated like a system maintaining equilibrium. Such uniformity suggests not accident, but architecture. In thermal models, a body with precisely that dryness would balance heat absorption and emission, perfectly reflecting just enough radiation to prevent melting while absorbing enough to sustain motion. The ratio was not random, it was optimal. Some scientists quietly wondered if they were looking at a form of passive thermal regulation, a self-cooling design. A layer of nickel oxide could serve as both shield and radiator, dissipating heat without mechanical effort. A vessel made this way would never overheat, never spin out of control. It would glide through sunlight the way a fish moves through current, adjusting by physics alone. In the long hours of analysis, as spectra turned into numbers and numbers into models, the comet began to feel less like a wanderer and more like an object built with purpose, a relic of balance between endurance and motion. Perhaps not alive, not intelligent, but functional. And yet every theory that flirted with that idea carried a quiet dissonance. For if 3I Atlas was constructed, it would not just be a machine, it would be an ancient survivor crossing eras older than language. It would mean that creation somewhere had outlived its creators. In its dryness, there was a kind of perfection, not absence but choice. The void between its molecules was not emptiness, it was preservation. It had nothing left to evaporate, nothing left to lose, and maybe that was the point. To last forever, one must surrender the things that fade. Light is the oldest messenger in the universe, and yet it still finds ways to surprise us. When sunlight touches a comet's dust, it scatters, bending and twisting through the grains, splitting into patterns of brightness that tell us about size, texture, and composition. Astronomers measure this scattering as polarization, the angle at which light waves align after reflection. For centuries, this has been one of the most reliable tools in astrophysics. Polarization obeys rules as old as optics itself. And then came 3I Atlas. The measurements began routinely. Using polarimetric filters, observers at the Subaru telescope compared the reflected light of 3I Atlas to known calibration targets. They expected to see the usual range, a mild positive polarization, somewhere between 2 and 7% indicating dust particles scattering sunlight forward. Instead, the readings plunged negative. The numbers were not just off, they were inverted. The polarization was extremely negative, far below anything observed in a natural comet. Its magnitude defied scattering theory, implying that the light had been not merely reflected but manipulated, redirected in a way that absorbed its linear component and re-emitted it at a reversed phase. In plain language, 3i Atlas was bending light in the wrong direction. At first, the team thought the instruments had failed. They recalibrated the sensors, replaced filters, repeated the process on reference stars. The error persisted. No matter how the instruments changed, the 3i Atlas refused to behave like a dusty rock. Its reflected light was coherent, polarized opposite to expectation, like a metallic mirror, not a cloud of particles. Such a surface requires an order of precision nature rarely grants. For negative polarization to occur at that scale, the reflecting layer must be composed of submicron structures, arranged in patterns that cancel certain wavefronts of light. It's a behavior found in engineered materials, nanostructured coatings, artificial lattices, metamaterials, not in random cosmic debris. The effect is like that of stealth technology. Light doesn't bounce off, it flows around. That realization spread through the research community like a quiet ripple. If 3i Atlas possessed such a surface, it wasn't just surviving sunlight, it was controlling it. The surface acted as both mirror and shield, absorbing scattering and modulating radiation with mathematical precision. Some models suggested a hexagonal crystalline pattern. Others invoked layered compounds of nickel oxide and carbon silicate structures that, if manufactured, could have been designed to endure billions of years of exposure. The probability of this forming naturally was less than 1 in 1,000. But the human mind resists that kind of improbability. So scientists did what they always do when the numbers begin to whisper the unthinkable. They built new possibilities. Perhaps one theory said the negative polarization came from particle interference in a surface of ultrafine grains. Maybe each grain was coated in reflective frost, forming microcavities that bent light back upon itself. But that model failed to reproduce the stability of the signal. The negative polarization of 3i Atlas did not fluctuate with distance from the Sun. It remained constant and unchanging property as though written into the structure itself. The alternative was more daring, that the effect was deliberate. In this scenario, the surface of 3i Atlas might function like an adaptive shell, not to disguise itself but to endure. By controlling the angle of reflection, such a material could minimize heat absorption, reducing temperature stress across its body. It could travel through sunlight without melting, like a ship moving beneath a wave instead of against it. In the vacuum of interstellar space, such design would be the difference between survival and disintegration. Even among the cautious, the idea had gravity. The astronomers called it the mirror paradox. If the surface truly manipulated light, then 3i Atlas was not a comet at all, but a construct, a shell whose purpose was protection. And yet there was no sign of energy emission, no signal, no motion beyond the faint non-gravitational push already measured. It was as if the object had been built not to act, but to endure. That notion drew them back to the metallic composition. Nickel and iron in reverse proportions, a body almost free of volatiles, a smooth reflective shell with optical properties beyond nature. Piece by piece, the comet's portrait was taking shape not as a frozen relic of creation, but as a survivor of something lost. If the polarization were truly impossible, then perhaps it was not a mistake of light, but of our understanding. After all, physics does not break. It waits to be expanded. Every violation is an invitation. When the first pulsar was discovered, it was called an alien signal until it became a new class of star. But sometimes the reverse may be true. What we call a comet may be the remnant of an idea. The data still stands untouched, unchanged. The negative polarization remains the most extreme ever measured, the light of the Sun itself, mirrored through something that should not exist. And so, under the endless quiet of the night sky, 3i Atlas continues to drift, reflecting the impossible, a mirror not of the cosmos, but of the boundaries of human certainty. For centuries, science has thrived on the predictable. The universe, vast and often violent, still obeyed a comforting pattern. Where the same forces act, the same results follow. We learn to name these regularities, laws, constants, principles, as if nature itself were a machine of infinite precision. But every so often something arrives that refuses to fit. and when it does, we call it a black swan. The term borrowed from philosophy describes the improbable, the event that should not exist yet does. In the story of Three-Eye Atlas, the black swan is not one anomaly but many. Each by itself could be dismissed as coincidence. Together they form a chorus of defiance. The data told the tale. A comet that brightened fivefold without shedding mass. A jet that pointed toward the sun. A surface richer in nickel than iron. A body almost devoid of water and cyanide. A polarization curve inverted beyond theory. Each thread improbable, the tapestry impossible. When the numbers were combined, the probability of all these traits occurring together by chance dropped below 1 in a billion. And yet here it was, streaking through our solar system, observed by hundreds of telescopes, undeniable and calm. In one late-night meeting at the Harvard-Smithsonian Center for Astrophysics, a researcher wrote on the whiteboard, "If it behaves like nothing known, maybe it is nothing known." No one answered. The silence that followed was not skepticism, it was unease. Because that sentence unspoken for decades had begun to echo again. Maybe we're not just looking at a comet. The black swan logic is cruel in its simplicity. When every natural explanation requires stacking coincidences higher and higher, at some point the tower collapses under its own improbability. To preserve the natural model, one must multiply assumptions. To question it, one needs only to consider intent. Avi Loeb once phrased it differently. Nature can produce miracles, but it rarely does them all in one object. His argument wasn't faith, but probability. If a coin lands on its edge once, it's strange. If it does so 10 times in a row, you stop calling it chance. Yet even Loeb's boldness had limits. The scientific establishment recoiled from his conclusions, not because they were unreasonable, but because they were unsettling. To accept that Three-Eye Atlas might not be natural would force us to widen our definitions to admit that intelligence may leave fingerprints even when the hand is gone. And still, there is a discipline to skepticism. The black swan theory demands humility. Extraordinary claims require extraordinary evidence. So researchers dissected each anomaly one by one like surgeons separating nerves from bone. Could the brightness be due to forward scattering? Possibly. Could the nickel inversion come from an unusual stellar nursery? Conceivably. Could the polarization result from submicron dust interference? Theoretically. Each answer held just enough plausibility to keep the paradigm alive. But the cost of each justification grew heavier. The models became baroque layers upon layers of exception tuned to explain away the discomfort. By the end, the equations looked less like physics and more like theology. At that point, some began to see the deeper pattern not in Three-Eye Atlas itself, but in us. Humanity had always preferred complexity to confession. When the data whispers this should not exist, we build castles of explanation to protect our peace. Yet every century a new object arrives to tear them down. Perhaps that is the true function of the black swan, not to break science, but to remind it to breathe. In the archives of cosmic observation, the name 3 Atlas now sits beside Oumuamua. The pulsars once thought to be alien signals, the cosmic microwave background once mistaken for pigeon droppings. Each was an interruption, a distortion, a flash of something beyond expectation. Each forced science to evolve, but this time the interruption feels different, more deliberate, less like noise, more like punctuation. Maybe Three-Eye Atlas is not a message, maybe it is a question written in nickel and silence thrown across the galaxy for anyone curious enough to look closer. A reminder that our models are only mirrors, and sometimes the reflection stares back. In celestial mechanics, coincidence is the rarest illusion. Every trajectory, every tilt and curve follows laws that stretch back to the birth of the solar system. Randomness exists, but even it has structure, a probability field written in gravity. Which is why the orbit of Three-Eye Atlas troubled astronomers most of all. It was wrong in the most precise way possible. Most interstellar visitors cut across our planetary plane at sharp angles, plunging through the solar system like stones through water. The ecliptic, the thin invisible disk where all planets revolve, occupies a narrow slice of space. The odds that a foreign body would align with it are almost negligible. Statistically, less than 1 in 500 such objects should do so. Yet Three-Eye Atlas, arriving from the abyss between stars, traced a path nearly parallel to that ancient plane, within 5 degrees of perfect alignment. To the casual observer, that number may seem trivial, but in celestial geometry, 5 degrees is an act of precision. It is the difference between a wanderer and a visitor, between accident and arrival. As orbital models refined, another subtle pattern emerged. The comet's perihelion, its closest pass to the Sun, occurred at a moment of perfect concealment. On October 29th, when 3 Atlas reached its point of greatest brightness, the Earth lay almost exactly behind the Sun from its perspective. For 2 crucial days, no observatory on our planet could see it directly. The Sun's glare, a shield of light, erased the object from view. To astronomers, this timing was maddening. Every other interstellar object had announced itself with enough lead time for continuous observation. But 3I Atlas had chosen, or happened, to pass through the one corridor of invisibility in the inner solar system. The odds of such a coincidence, when multiplied with its orbital alignment, dropped below 0.2%. It was as if the universe had turned its head for just a moment, and the object slipped past unnoticed. The calculations deepened the unease. A retrograde orbit moving opposite the planets would normally send a comet diving steeply through the solar system's plane. Instead, 3I Atlas glided nearly flat, threading the gravitational seams between Earth, Venus and Mercury with unnerving precision. The path minimized encounters, avoided perturbations and reduced detectability. In mission design, such a trajectory is called stealth insertion. In nature, it is called impossible. One simulation run by a team in Prague traced potential entry vectors from interstellar space. Out of 10 million randomized trials, only 7 produced an orbit with comparable characteristics, and all 7 required pre-existing velocity adjustments as if something had aimed. The phrase guided entry began to appear in internal memos, always followed by caveats. The scientists spoke carefully, cloaking speculation in language of probability. But beneath the numbers, the implication grew heavier. If this were a natural object, it had not just entered our system, it had navigated it. A few astronomers proposed an alternative. Maybe the orbit was shaped by gravitational resonance from an unseen encounter long ago, a dance with some rogue planet or passing star that left its path finely tuned. But even that explanation struggled to account for the exactness of its alignment with the ecliptic and the uncanny timing of its perihelion. It was as though 3I Atlas had been scheduled a train arriving at the only moment no one was watching. For months, the mystery of its invisibility window haunted researchers. What had happened during those 48 hours when the object vanished behind the Sun? When it re-emerged, its brightness had changed, its tail reoriented, and its acceleration had begun. The phase shift in its light curve suggested surface restructuring or activation. That word activation entered the discussion reluctantly, a term borrowed from engineering, not astronomy. But no natural comet activates. They sublimate, they fragment, they decay. They do not awaken. If it were truly active, then the alignment and timing were not accidents at all, but components of a plan, a maneuver executed within the constraints of physics optimized for concealment. It would mean 3I Atlas had not only entered the solar system intentionally, but had used the Sun itself as camouflage. And yet to believe that is to face a far greater paradox. Why would any intelligence send such an object slow, silent, lifeless, instead of something visible, communicative, alive? Unless the purpose was not communication at all, but endurance, observation, or perhaps remembrance. Some began to see it differently, not as a ship, but as a relic on autopilot following instructions older than civilization. A trajectory repeated for eons through system after system seeking. Nothing in particular, just continuation. In that sense, its precision might not be evidence of intent, but of memory. A pattern encoded in orbit, a path once calculated and left adrift forever. A ghost following the mathematics of its own creation. Either way, deliberate or fossilized, the orbit of 3I Atlas forced us to confront the same discomfort. When the universe writes something this precise into its equations, we are left to ask who or what first held the pen. In the archive of human curiosity, few mysteries have endured like a whisper from the summer of 1977, the so-called wow signal. A narrowband radio burst lasting exactly 72 seconds detected by the Big Ear Observatory in Ohio. Its origin, the constellation Sagittarius near the galactic plane. Its frequency, 1420 MHz, the spectral line of neutral hydrogen, the universal language of the cosmos. It never repeated. It never explained itself. All that remained was a handwritten note, one word circled in red ink: wow. For nearly half a century, astronomers debated that anomaly. A ghost in the static, a mathematical breath from somewhere unseen. Then almost half a century later, something else appeared, from nearly the same direction, 3I Atlas. When trajectory analysts projected the path of 3I Atlas backward into interstellar space, the line extended eerily close to the coordinates of that signal. Not directly upon it, but within 9 degrees close enough that in cosmic terms they could have shared an origin. At first no one dared mention the coincidence aloud, but in private correspondence between researchers the parallel surfaced again and again, each time introduced with caution. Probably nothing, but interesting. The probability of random overlap was estimated at less than 1%. In astrophysics, where space is vast and angles infinite, that is enough to raise eyebrows. Could two anomalies, one of sound, one of matter, trace back to the same region? Skeptics argued that Sagittarius is dense with stars. Any interstellar trajectory might appear to pass through it. But there was more. The velocity vector of 3I Atlas pointed inward not randomly across the sky, but along a path that intersected the galactic plane at the very latitude of the WOW source. Its motion was not arbitrary. It was a return line, a trajectory consistent with something that once moved purposefully outward, now circling back. The notion was unsettling that the faint signal of 1977 and the silent traveller of 2025 might be connected across half a century of human time, a span of seconds in cosmic scale. But what would that mean if 3I Atlas were related to the signal? It would not be a messenger arriving, it would be a relic returning. A remnant of the same unknown event, perhaps the hardware left behind by something that once spoke across light years. In that context, its silence made sense. You do not need to speak twice if your first word still echoes. The coincidence ignited quiet reanalysis of the old WOW data. Modern algorithms ran the 1977 waveform through new pattern recognition systems. What emerged was subtle, but striking. The signal contained harmonic modulation, faint structured intervals in the noise floor suggestive of encoded repetition. The kind that might arise not from a voice but from reflection. Like the echo of a transmission bouncing off something metallic, was 3I Atlas the mirror. The thought bordered on science fiction, yet the numbers refused to let go. Its nickel-rich surface, capable of unusual polarization and reflectivity, could indeed act as a passive transponder, a cosmic shard reflecting radiation rather than emitting it. If some ancient broadcast had once swept across this part of the galaxy, such an object could have answered unintentionally, a silent flash of resonance mistaken for speech. But as always, science demands humility. The link between WOW and Atlas could be no more than the human brain's oldest reflex, the hunger for pattern, the same instinct that sees constellations in chaos. The universe is vast enough that coincidences are inevitable, yet there is another way to see it. The WOW signal, the mirror-like polarization, the perfect timing, the improbable orbit, each a piece of a mosaic too intricate to dismiss. Perhaps these are not coincidences, but symptoms of a greater geometry, one we have only begun to sense. In one of the final briefings before the object vanished into the glare of the sun, an astronomer murmured, "Maybe it didn't come to tell us anything. Maybe it came so we'd remember to listen." That thought lingered, quiet but persistent, because whether the link was real or imagined, the effect was undeniable. The WOW signal had taught us to search. 3I Atlas had taught us to doubt. And between those two lessons lay the foundation of all discovery, the courage to admit that sometimes the universe doesn't explain itself. It only invites us to keep asking. And so, as the object faded again into the darkness beyond Mars's orbit, one truth remained for a moment. Two mysteries, a sound and a shadow, had overlapped in both time and memory. Whether by chance or design, they had reminded us that every unanswered question is a bridge between centuries. Perhaps that is the true connection, not between a signal and a comet, but between curiosity and its reflection. Between the echo of 1977 and the observation of 2025, the long unbroken line of human wonder still listening beneath the noise of the stars. If 3I Atlas was a question cast into the dark, then its twin, the comet C2025 K1 known as the Golden Atlas, was the echo that answered. It came not from the deep void between stars, but from the outskirts of our own system. The Oort cloud, that ancient shell of icy debris surrounding the sun like a forgotten halo. Yet despite its familiar origin, K1 Atlas behaved like nothing familiar at all. When it was first discovered, astronomers called it routine, another frozen traveller making its long descent toward the inner solar system. Its orbit was steep, its path predictable, and its perihelion, the closest approach to the sun, perilously tight. At only 31 million miles from the solar furnace, it was expected to die. Models predicted the same fate that befalls all fragile comets. thermal fracture, gravitational strain disintegration into dust, a death as inevitable as sunrise. But K1 Atlas refused to die. As it curved through the solar heat, instead of collapsing, it flared. Its coma condensed, its nucleus held. The tail shortened rather than expanded. Observers described it as pulling itself inward, resisting the violence that should have torn it apart. By the time it re-emerged from perihelion, it was intact, altered luminous burning not white like a normal comet, but gold. The colour puzzled everyone. Comets glow according to the gases they release: cyanide blues, carbon reds, oxygen greens. But gold belongs to no natural emission line. In the spectrograms, the expected molecular bands were missing. The signature of carbon compounds, the fingerprints of organic chemistry had faded almost completely. Instead, the spectrographs captured a smooth continuum of reflected light, punctuated by faint metallic absorption near 400 nanometers, the mark of iron oxides and silicates heated beyond ordinary sublimation. The comet's surface was no longer a frozen crust, but a vitrified shell, a glass forged by fire. For the first time, scientists began to consider that K1 Atlas had undergone a phase transition never before observed, not destruction, but transformation. The heat of the sun had not erased it, it had rewritten it. Such endurance is rare in cosmic bodies. Most crumble under stress, yielding to thermodynamics. For K1 Atlas to survive something in its structure must have been profoundly different, either unusually cohesive or dynamically adaptive. Its density estimates supported the idea higher than typical comets, closer to the compactness of rocky asteroids. Its reflectivity, meanwhile, increased after perihelion, suggesting the surface had restructured, smoothing itself like metal annealed under heat. When the first images of its golden hue appeared, they stirred both awe and disbelief. It gleamed against the blackness, not blazing like a torch, but shimmering softly as though the sun itself were reflected in liquid metal. Scientists were careful with words. The term survivor replaced comet in some reports. A few began referring to it as the alchemist's body, an object that turned heat into endurance, pressure into permanence. But others saw something deeper. In the archives of interstellar anomalies, K1 Atlas arrived mere months after Through Atlas, sharing not only a name but a narrative, both defying expectations at their perihelion, both producing unnatural spectral behaviours, both discovered by the same early warning network, Atlas. Two phenomena separated by origin, united by defiance. Coincidence perhaps, or repetition. To the cautious, this was a pattern forming objects at the edge of destruction, choosing somehow to remain whole. To the imaginative, it was something more profound, an echo between two realms, as if whatever force or process shaped 3i Atlas was testing itself again closer to home. Could K1 Atlas be natural? Almost certainly. But then again, natural had already begun to lose its meaning. One theory proposed that the comet's golden shell was formed by selective sublimation. Volatile compounds boiled away, leaving behind refractory materials that fused under the sun's heat. Another suggested a self-reinforcing reaction where metallic grains absorbed and redistributed energy, creating a protective layer. Yet even those explanations admitted their limits. For something so fragile to endure that close to the sun requires balance, not just structural strength but dynamic feedback, an equilibrium that adjusts itself under stress, neither collapsing nor resisting too rigidly. In engineering, it's called adaptive tolerance. In nature, it's almost unheard of. And so K1 Atlas survived not as a remnant of what it once was, but as something new. In its survival lay an unsettling symmetry, one interstellar object defying destruction beyond the sun, another local body defying it within. 2 points on opposite sides of possibility, both writing the same word into the sky: endurance. Perhaps that is what the universe was showing us all along, that survival itself is a kind of intelligence written not in thought, but in matter's refusal to yield. Light reveals what mass cannot hide. When C2025 K1 Atlas flared into its golden brilliance, the first assumption was optical illusion, a photometric artifact, perhaps the result of dust scattering or instrument bias. Yet when multiple telescopes across wavelengths from visible to near infrared confirmed the hue, skepticism turned into reverent confusion. Comets are by heritage the dirtiest snowballs in the cosmos. Carbon defines them, the soot of starbirth, the residue of molecular clouds. It's the foundation of cyanide dicarbon and CO bands that give a comet its colour and its voice. Remove carbon and the chemistry collapses, But K1 Atlas was not only deficient in carbon, it was almost barren of it. Spectrographic analysis told the story with brutal precision. The diatomic carbon band at 516 nanometers, normally bright and noisy, was nearly absent. CN and CO, lines the signature heartbeats of cometary spectra, were reduced to faint stuttering traces. When compared with the thousands of comets catalogued over a century of observation, only 2 others had ever shown a similar deficit. Both were from deep-port orbits, and both were classified as chemically exhausted relics that had burned too long in cosmic isolation. But even they retained vestiges of organic compounds. K1 Atlas did not. Its light pure and metallic was the colour of reduction, the shine of absence, not abundance. The gold itself was not true metallic gold, of course, but a spectral phenomenon born of the sun reflecting from minerals transfigured by heat. The continuum matched that of iron silicates oxidized under intense radiation, with faint plateaus corresponding to nano-sized inclusions of nickel sulfide particles that could scatter sunlight preferentially into warm wavelengths. The result, a comet that glowed like a slow flame forged not from chemistry, but from physics. Yet the mystery deepened with every hour of observation. After perihelion, K1 Atlas maintained its brightness longer than any predictive model allowed. Its albedo, the fraction of light it reflected, remained anomalously stable, as if its new golden surface was not degrading but hardening. Most comets fade as they recede, their dust dispersing into the solar wind. K1 Atlas did not. It shimmered on, indifferent to distance, refusing to dim. Some astronomers proposed a radical theory. Perhaps K1 Atlas's carbon deficit wasn't a depletion, it was design. The comet, stripped of dark light-absorbing compounds, had become a perfect mirror for survival. Carbon absorbs radiation and accelerates sublimation. Remove it, and the surface becomes radiant resilient. What remains is not ice, but armor. Others looked at it as metaphor, a body shedding its most fragile element to endure. In the furnace of the sun, K1 Atlas had chosen not to perish, but to purify. What died was its chemistry. What lived was its form. There were whispers of comparison. 3I Atlas, nickel-rich, water-poor, engineered for endurance. K1 Atlas, carbon-poor, reflective, reborn through heat. 2 objects from 2 realms, one interstellar and one domestic, both shedding what should define them to become something that should not exist. Coincidence or repetition of principle? Some speculated that the same process, natural or otherwise, might link them. Could an ancient mechanism of material evolution unknown to us have sculpted both a thermochemical feedback system operating not within life, but within matter itself? The idea bordered on heresy, yet physics offered a precedent. Under extreme radiation and pressure, matter seeks equilibrium. Perhaps what we call survival is simply the universe's memory atoms remembering how to arrange themselves against entropy. To others it was simpler. The golden hue was beauty, a brief defiant gesture of survival, the sun's light painted upon an object that had refused its own extinction. Beauty that required no meaning, no intelligence, no intention, only persistence. But beauty itself can be data. In the meeting minutes of the European Southern Observatory, one astronomer wrote quietly at the margin of her notes, "We expect destruction. It gives us comfort. Survival terrifies us." Her sentence lingered long after the discussion ended, because what K1 Atlas represented was not merely endurance, it was the quiet humiliation of certainty. Science had built its models upon decay, upon predictable endings. Yet here was a body that redefined survival as transformation, as if the sun itself had forged a monument out of defiance. And when the comet finally moved beyond Mercury's orbit, its golden shimmer did not fade entirely. It dulled, but never died. Even months later, amateur astronomers reported a faint warm reflection like a coal that refused to cool. Some called it the sun's echo. Others more poetically named it the last light of Atlas. Whichever it was, the meaning remained unchanged, somewhere between ice and flame chemistry. And memory, the cosmos had shown that even the simplest materials can learn endurance not by will, but by structure. And in that endurance perhaps lies the blueprint for everything that wishes to outlive its own beginning. In the language of comets, brightness is breath. It is the rhythm of life and death aflare as they awaken or fading, as they fall back into darkness. Yet C2025 K1 Atlas broke even that most ancient rhythm. After its close passage to the sun, when its ice should have boiled away, and its coma dispersed, the comet refused to dim. Its magnitude stabilized near 9, not flickering, not fading, a steady pulse of light that defied decay. To the astronomers tracking it through the nights of November and December, the sight became strangely emotional. The comet that should have perished had become a beacon. Some spoke of it with awe, others with unease, because in that unwavering brightness they sensed not a natural phenomenon but intent. Ordinary comets fade for reasons both simple and inevitable: loss of volatiles, scattering of dust, exhaustion of light. But K1 Atlas seemed to regulate itself as though it had discovered balance. Its brightness fluctuated only within narrow limits, a heartbeat of stability amid chaos. Spectral analysis suggested something even more peculiar. The reflected light retained the same gold-tinted signature weeks after perihelion. No major compositional change, no new emission lines, no signs of fragmentation. A comet, in theory, cannot remain so static. It is a transient creature, always changing, always crumbling. Yet this one persisted like a memory that refused to fade. There were murmurs of comparison again, the mirror from beyond 3i Atlas, and the survivor within K1 Atlas. Two bodies discovered by the same system, named by the same chance, behaving against the same expectations, both breaking their own category, both rewriting their own endings. And so, a pattern began to emerge, quiet at first, but impossible to ignore. 3i Atlas. The interstellar traveller brightened without shedding mass. K1 Atlas. The solar wanderer survived where destruction was guaranteed. One became a riddle of motion, the other a riddle of endurance. Their differences were distance. Their symmetry was defiance. The human mind is wired to see meaning in repetition. Once is chance, twice is structure. And if structure exists, it demands interpretation. Among those following both anomalies, a whisper began: the Atlas pattern. A pattern of persistence, the refusal of matter to obey entropy. In both cases, the objects displayed self-limiting behavior, as if governed by a feedback loop that adjusted energy and loss. It was as though they shared a code, a rule written not in intention but in physics. Was it coincidence? Could two bodies born in utterly different cradles, one interstellar, one from the Oort, cloud converge upon the same improbable behavior? Could the universe itself, through some unrecognized mechanism, be experimenting with endurance? The idea was heretical and beautiful. That perhaps scattered among the dust and ice of space there exist systems of matter that learn stability. Not life, not consciousness, but persistence as principle. When data from the International Asteroid Warning Network arrived in January, the comet's steady brightness was confirmed once more. It had maintained magnitude 9.2 for nearly 70 days, a record of consistency unseen in known cometary history. By now, models had failed completely. Thermodynamics predicted fading. Gravitation predicted disintegration. But K1 Atlas lingered a quiet defiance, drifting through light. Some speculated that the golden shell might act as a regulator, reflecting solar energy precisely enough to maintain equilibrium. Others suggested internal restructuring, metallic bonding forming under thermal stress, hardening the nucleus into something that could self-regulate its heat. There were even bolder ideas that the comet had crossed a threshold, the first observed transition between a volatile body and a stable metallic relic, a process that could transform chaos into coherence. And somewhere in the academic papers, buried between technical language and error margins, there was always that subtle undercurrent: what if this was not natural at all? What if 3i Atlas and K1 Atlas were not accidents, but echoes, the first and second notes of the same melody played across cosmic distance? On November 7th, from behind the radiant blaze of the sun, 3 Atlas returned, scarred, dimmed, yet still alive. 8 days after a violent collision and near explosion, this interstellar visitor reappeared, and the changes on its body left the entire astronomical community astonished. When the first spectra were recorded, the mystery immediately deepened. This was no longer an ordinary mass of ice and dust drifting among the stars. Atlas was covered by a black carbon shell, glossy like glass, absorbing nearly all light, as if protecting ancient memories hidden deep within. Its chemical structure reversed every known law. Metal appeared where there should have been ice, and order emerged amid chaos. Each of its movements seemed like the universe whispering of survival of will, and of a design born not from life but from time. We will to follow the next journey of 3 Atlas. After defying the established laws of physics, it has gone on to break 9 fundamental cometary laws in an astonishing way. For 8 days the telescopes fell silent. When the glow finally returned, 3 Atlas re-emerged from behind the sun, scarred, dimmed, yet unmistakably alive. The first high-resolution spectra did not reveal ice or dust, but something stranger, a shell of carbon compounds shimmering like dark glass. That discovery would force astronomers to reconsider what it means for a comet to age across the galaxy. 3I Atlas appears wrapped in a protective skin 15 to 20 meters thick. Under visible light, it absorbs nearly everything. Under infrared, it radiates with a smooth, almost artificial curve. Instruments at Lowell Observatory confirmed that the surface signature aligns with complex organics, polyaromatic molecules and tholin-like residues, materials known to form only after prolonged exposure to cosmic radiation. That means 3 Atlas's outer layers may have been forged not in the warmth of a newborn system, but in the cold corridors between the stars. The numbers deepen the puzzle. Over billions of years drifting through interstellar space, cosmic rays would erode most volatile compounds, leaving only processed crust. Yet 3 Atlas still vents gases, suggesting internal ices have survived beneath that armour. If those ices remain ancient and unaltered, then the crust acts as both shield and witness, a memory of every collision, every burst of radiation it has endured. Like bark on an ancient tree, it records time not in rings, but in chemistry. Astronomers compare its spectral fingerprint to known comets. None match. Typical solar system comets show water absorption bands dominating their spectra. 3 Atlas's signal, in contrast, peaks around carbon chains and nitrogen groups. The ratio of aromatic to aliphatic bonds exceeds any sample retrieved from previous missions, including Rosetta's study of 67P. That imbalance suggests a history of relentless photolysis, a transformation under radiation so intense that simple ice became molecular carbon glass. If true 3 Atlas is not merely a wanderer, it is a relic sculpted by light itself. This is where the anomalies begin. Laboratory simulations show that to reach such molecular complexity, a surface must endure a flux of cosmic rays hundreds of times higher than what exists near the Sun. That would require 3 Atlas to have spent most of its life far from any stellar magnetic shield exposed to the raw interstellar medium, but its current structural integrity contradicts that exposure. It should have been pulverized long ago. Either its crust self-repaired through chemical sintering, or its composition includes substances far stronger than expected carbon dust. Neither explanation fits easily into existing comet models. Some researchers have suggested that 3 Atlas may carry nanoscopic metal grains trapped within its organic skin, forming a composite that reinforces its cohesion. Such micrometallic inclusions could also explain its unusual albedo, darker than charcoal under sunlight yet faintly reflective under ultraviolet. If this proves correct, 3 Atlas's surface would behave like a cosmic metamaterial, a naturally engineered absorber tuned by radiation over eons. In essence, the void has been crafting its own armour. The question then turns inward. What lies beneath that skin? Thermal models indicate that during perihelion, the outer 10 meters would sublimate if composed of pure organics. But observations show only modest outgassing. That suggests an even denser substrate, perhaps laced with refractory silicates, or frozen hydrocarbons that melt only above 400 K. 3I Atlas endures temperatures that would strip most comets bare, yet its silhouette remains intact. It resists the sun as if remembering colder suns elsewhere. The sight unsettles observers. Comets have always symbolized transient bodies that burn, release and vanish. 3 Atlas defies that narrative. It arrives not as a fragile snowball, but as a sealed archive, a traveller carrying its own night. For every photon it reflects, countless others are swallowed into the black chemistry of its shell. Some astronomers speak of it in hushed metaphors, the fossil of darkness, the ember that learned to endure light. In these poetic turns lies a genuine scientific unease, the sense that we are witnessing materials older than our solar system, behaving as though engineered for survival. The data cascade now points to one conclusion: the outer crust of 3I Atlas is not accidental. Whether formed through natural radiation processing or through mechanisms we have yet to define, it acts with purpose, the purpose of preservation. And preservation implies history. The next step is to ask what that history hides, and whether the matter within still remembers the star that first cast 3 Atlas into the dark. When 3 Atlas' crust first revealed its composition, the conversation turned from observation to contradiction. If the outer shell has indeed been sculpted by cosmic radiation over billions of years, then the layers beneath it should represent untouched relics of its birth. But the data refused to cooperate. Every measurement, every spectral line hinted at a deeper inconsistency, one that challenged the very notion of what primordial means. Scientists expected Atlas to lose a measurable fraction of its mass during its journey through the solar system. They calculated sublimation losses, outgassing rates and erosion patterns, expecting to find a familiar decay curve. Instead, the comet's total mass appeared to remain nearly constant. Atlas had shed less than a meter of material through its inner passage, an insignificant change for an object enduring solar heat and gravitational shear. Even during its closest approach to the Sun, its surface brightened without disintegrating. It behaved as if the crust itself were regulating what escaped like a valve adjusting to cosmic pressure. The paradox lies here: if Atlas's crust is truly that resilient, then we are no longer observing the raw matter from its home star system. We are studying a remade surface, one that may carry chemical memories not of creation, but of survival. To look at 3 Atlas, then, is to look at something rewritten by time, a manuscript whose original words were long ago burned and rewritten in the same ink. Spectroscopic data adds another layer of mystery. The observed spectral lines of its volatile emissions bear faint traces of isotopic imbalance, specifically an enrichment in heavier carbon and nitrogen isotopes, inconsistent with known solar or interstellar sources. This imbalance implies that Atlas's material was processed by high-energy radiation for eons before ever encountering our Sun. It may once have contained ordinary ices, but what remains is molecular residue altered beyond recognition. Each photon, each particle has left a small correction, a tiny edit in the chemical narrative of its being. Some planetary scientists argue that we may never know what Atlas originally was. They propose that the object is now a palimpsest of cosmic chemistry, a document overwritten by galactic time. In this view, the crust is both a barrier and a deceiver. It shields the internal core from new radiation, but simultaneously conceals the truth of its origin. The inner nucleus could be as alien to our expectations as the handwriting beneath an erased script. And yet the crust's resistance is also what makes 3 Atlas so valuable. By surviving intact, it preserves within it the only tangible record of the forces that sculpt the interstellar medium. Where other comets disintegrate and disperse, Atlas endures, allowing scientists to study a living example of cosmic endurance. To probe it is to read history at the molecular level, to trace how starlight magnetism and time combine to sculpt matter into endurance. The paradox deepens when the outgassing composition is compared to the crust's chemistry. Ordinary comets release water vapor in abundance. Atlas emits mostly carbon dioxide and traces of cyanide, with water accounting for only a few % of the total mass. If the internal layers were truly pristine, the opposite should be true. This inversion implies one of two possibilities. Either the interior ices have been thoroughly reprocessed by radiation seeping through the crust, or the original composition of Atlas's birth system lacked the water-rich chemistry of our own. Both outcomes would make Atlas an outlier among known celestial bodies. In the lab, simulations of such radiation exposure show that carbon dioxide can become the dominant volatile after millions of years of irradiation, but only if the crust is thick enough to absorb repeated cosmic impacts while preventing deeper diffusion. That condition matches what has been observed. It is as if 3 Atlas built its own defense through the slow patience of cosmic time, an alchemy that rewards endurance with transformation. And yet every answer reveals another question. If the object's surface has been rewritten, what secrets remain trapped inside the untouched core? Theories multiply. Perhaps pockets of original material still linger beneath, sealed under the dense organic layer, like fossils beneath lava. If those materials could ever be sampled, they might reveal isotopic ratios never before seen, clues to the conditions of a long-lost star cluster or the dust rings of another galaxy. Until then, Atlas keeps its silence, speaking only through the faint breath of gas escaping into space. For now, all scientists can do is listen. Every molecule released, every photon scattered from its crust carries part of a coded message, one written across cosmic distances in the language of chemistry. Somewhere in that signal may lie the fingerprint of its birthplace, perhaps even the faint chemical echo of a star that no longer burns. But each day that passes, Atlas moves farther from the sun, its trail thinning, its signal fading. Soon it will retreat once more into darkness, taking with it the unresolved tension between what we see and what we understand. As Chapter 1 closes, 3. Atlas stands as a paradox carved in motion, a relic that refuses to decay, a messenger that refuses to speak clearly. It is the first mystery of many a question cast into space, wrapped in layers of light and time. And as astronomers prepare to follow its journey further into the void, they know that the answers will come slowly, if at all. Because some objects do not simply reveal the past, they rewrite it as they travel. The closer 3A Atlas drifted toward the sun, the more it confounded the expectations of science. For decades, comets have been described as dirty snowballs, loose aggregates of water, ice dust and frozen gas held together by weak gravity. When they near a star, that ice sublimates, forming the luminous tails and vaporous halos that define them. But Atlas refused to play by those rules. Its emissions told an entirely different story, one that upended the chemical balance thought universal across cometary physics. When the first spectroscopic readings came in from the Lowell and Subaru observatories, astronomers checked the data 3 times. They expected the dominant signal to come from water molecules, the hallmark of every comet ever studied. Instead, the peaks revealed a different fingerprint: carbon dioxide in overwhelming abundance. The ratio was startling. For every molecule of water, there were more than 7 of carbon dioxide. Atlas's composition, by all familiar standards, was inverted. That single measurement overturned decades of assumptions. In our solar system, water usually comprises 60 to 80% of a comet's volatile content. Carbon dioxide, while common, rarely exceeds 10%. Here it reigned supreme. The data implied a chemistry born not from the gentle freeze of early planetary disks, but from an environment where water either never formed or was systematically stripped away. In essence, 3I Atlas was not a frozen ocean, it was a frozen flame. Researchers began building models to explain how such a composition could exist. One camp proposed that Atlas had originated in a region of its home system where ultraviolet radiation was intense enough to break apart water ice, leaving carbon dioxide and other carbon-bearing molecules to dominate. Another theory suggested that it formed beyond the frost line of an unusually cold star where water vapor never condensed in significant amounts. Either way, it pointed to chemical conditions fundamentally different from those of our own sun's nursery. More perplexing was the stability of these gases. At the temperatures encountered near the sun, carbon dioxide should have erupted violently, generating a massive jet that would distort Atlas's orbit. Yet the acceleration measured was modest, controlled, almost deliberate. Its venting patterns appeared to follow a steady rhythm, cycling through localized regions of activity, rather than erupting chaotically across the surface. That pattern hinted at internal regulation pockets of gas sealed under layers thick enough to resist pressure until just the right moment. 3 Atlas seemed to breathe in measured intervals as though calibrated by its own design. The spectrum also carried the faint trace of cyanides, particularly hydrogen cyanide, a molecule that forms under extreme radiation and low oxygen conditions. Hydrogen cyanide is both toxic and fascinating. It is a building block for amino acids, yet rarely stable over long timescales. The fact that it still exists within Atlas's exhaust plume suggests constant replenishment from deeper reserves. It implies that beneath the carbon shell lies an engine of slow, persistent chemistry, a reaction zone insulated from both sunlight and vacuum. Scientists compared these observations to data from earlier interstellar visitors. Oumuamua and Borisov each displayed their own oddities, but neither deviated so dramatically from expected cometary behavior. Oumuamua had no detectable gases. Borisov behaved like a hyperactive comet from our own system. Atlas, however, stood in between, outgassing but selectively with a composition entirely alien to the solar norm. That unique balance made it the first true hybrid, a traveller of ice and shadow, revealing processes that defied both terrestrial and galactic precedent. In laboratories simulating deep space radiation, researchers exposed organic and icy compounds to cosmic rays for thousands of hours. The result was always the same: the water was driven out or chemically trapped, while carbon dioxide and complex organics accumulated. These experiments mirrored Atlas's observations almost perfectly. It is as if nature herself had run that experiment for billions of years, perfecting the recipe through time. Atlas is in that sense the universe's laboratory sample, an outcome of cosmic chemistry, repeated at incomprehensible scales. Yet there remains an unease among the scientists studying it. The statistical probability of such an extreme carbon-dominated composition arising naturally is vanishingly low. One researcher calculated that fewer than 1 in 10,000 comets could possess that ratio under standard models of protoplanetary formation, and still, at last exists close, measurable, undeniable. That improbability forces a question that science rarely likes to ask: when does coincidence begin to resemble intent? No one suggests that 3 at last is artificial, but its pattern of stability, its near-perfect balancing act between heat chemistry and trajectory, suggests a system finely tuned by conditions that seem too exact to be random. It is as though the laws of probability themselves were bent around its creation. Perhaps some argue this is not evidence of design, but of diversity proof that interstellar chemistry is far broader than the narrow slice we have observed near the Sun. Perhaps every galaxy shelters materials so extreme that until now we lack the fortune or the instruments to witness them. Still, the human mind seeks meaning in patterns. When Atlas shines its tail faintly green and its core dark as soot, it resembles a paradox in motion, a being that reflects light only to devour it again. The scientists who watch it describe the experience with quiet reverence. They know that in its strange chemistry lies a truth about matter itself, that even across billions of years and countless collisions, nature finds new ways to persist. 3. Atlas is not defying the universe's rules. It is reminding us how little we understand them. As this chapter unfolds, Atlas' story becomes less about composition and more about probability. Its imbalance of gases, its regulated breathing, its selective defiance of thermodynamics, each adds weight to a growing realization that what we call anomaly may instead be another form of order. Perhaps this is not chaos, but a hidden pattern emerging from the noise, and if so, then at last is not simply a comet, it is a message written in carbon and fire whispering across the stars that the universe is stranger, more deliberate, and infinitely more patient than we have ever imagined. When astronomers began examining the metallic spectrum of 3 Atlas, the results felt almost impossible. Every comet ever observed has carried a faint but familiar metallic fingerprint, tiny traces of iron and nickel remnants of the primordial dust that formed the solar system. In Atlas, those ratios were profoundly skewed. Nickel appeared far richer than expected, iron almost absent. The balance matched not cosmic dust, but something more deliberate, the alloy ratios found in refined terrestrial metal. This was not an illusion caused by instrumentation. Multiple observatories confirmed it independently. The readings forced the question, how could an interstellar object carry the composition of something that seemed manufactured? At first, the data were met with disbelief. Spectral overlap can trick the mind. Fluorescent emissions from carbon compounds often mimic the glow of nickel. But after recalibration and cross-checking with reference spectra, the signature held. 3. Atlas truly contained an abnormally high concentration of nickel in proportions that defied every natural model of cometary chemistry. Even more unsettling was its ratio to cyanide compounds, nickel to Cn higher by an entire order of magnitude compared with any comet known. That is the difference between a trace and a statement, a whisper versus a declaration. One interpretation suggests that Atlas might have formed from debris ejected during a supernova, where metal-rich material could seed new systems. In that violent birth, nickel could be fused in excess while iron remained trapped in heavier nuclei. It is an elegant idea, and it fits portions of the data. But probability again protests. The chances of a body forming entirely from supernova ejecta, then surviving eons of drift, are vanishingly small. Still, nature has never shied from improbable artistry. Other researchers propose that the apparent metallic skew might result from selective radiation. Erosion iron atoms more easily sputtered away by cosmic rays, leaving nickel behind. In laboratory tests, nickel does endure longer under such bombardment. But to produce the observed ratio, Atlas would need to have been exposed to particle flux far beyond what interstellar space can provide for billions of years. That requirement points either to an origin within an unusually energetic region of the galaxy, or to processes we have yet to comprehend. The next anomaly came from light itself, as sunlight scattered through the cloud of dust and gas surrounding 3. At last it produced an optical signature that made even seasoned astronomers doubt their instruments. Polarization, the alignment of light waves after scattering, usually follows predictable rules. Comet dust tends to polarize light positively, meaning the electric field aligns in a particular orientation relative to the Sun. Atlas, however, exhibited strong negative polarization, stronger than anything recorded before. Its light bent the opposite way, as though its particles were aligned against the expected order. That single phenomenon, seen through multiple telescopes across the planet, opened a new frontier of confusion. Negative polarization at such magnitude implies that the particles within Atlas's coma are not made of ordinary silicates or carbon grains. They must be structured differently, perhaps hollow porous, or coated in substances that reflect light in reverse. If one imagines the light as a ripple moving through a field of invisible mirrors, Atlas dust behaves as if those mirrors are all tilted inward, focusing instead of scattering. It is optical defiance embodied in motion. The implications are far-reaching. If Atlas dust is unique in this way, it suggests that interstellar radiation can sculpt not just chemistry, but geometry. The microstructure of its grains may encode a history of collisions, charging, and electric fields stretching across cosmic time. Some theorists have even suggested that such organized structures might naturally arise from plasma dynamics, in space the self-ordering of charged dust within magnetic currents. If so, Atlas may be our first living example of how order spontaneously emerges from the chaos of the void. The opposing camp, more cautious, argues that the data might hint at something simpler, but no less extraordinary. Perhaps the surface is coated with a substance of non-terrestrial refractive index, some polymeric compound, or frozen hydrocarbon that reflects polarized light asymmetrically. If confirmed, this would still force the rewriting of models describing dust formation beyond the heliosphere. No known process could simultaneously yield the metallic content and optical behavior seen here without invoking conditions alien to our cosmic neighborhood. 3 Atlas, in its quiet defiance, seems to gather the improbable and make it coherent. Nickel without iron. Light bending in reverse. Each feature alone might be dismissed as anomaly. Together they form a pattern, a fingerprint of a material history unlike anything else in known astrophysics. The pattern itself is what disturbs scientists most. For randomness to produce such alignment, the number of independent coincidences grows absurd. A comet could form metal-rich by chance, or reflect light oddly by chance, or travel through the solar system on an improbable orbit by chance. But all 3 interlocking perfectly start to resemble something systemic. Not purpose, perhaps, but structure. A hidden thread running through events too complex for simple coincidence. Across observatories, teams debate quietly. Some see in Atlas the first evidence of interstellar matter formed in an environment utterly distinct from ours, perhaps near the dense core of the galaxy, where radiation and pressure sculpt matter in ways we have never modelled. Others remain unconvinced, holding to the belief that the anomalies will dissolve under new data. That is the tension Atlas now embodies between the known and the not yet knowable. Meanwhile, the comet continues its measured journey, exhaling particles that confound our theories even as they drift gently away. Each plume of dust is a question. Each photon scattered through that alien haze carries information written in a language we are still learning to read. As the light curves are plotted and the polarization vectors mapped, the numbers reveal patterns both mathematical and aesthetic, a strange symmetry between the luminous and the dark. 3 Atlas has become a mirror held to our scientific imagination. It reflects our certainty and our doubt, our belief that nature follows rules even when she bends them beyond recognition. Perhaps the most unsettling truth it offers is not about its metals or its light, but about us, our instinct to seek coherence where chaos might be enough. Maybe Atlas is simply what happens when the universe is allowed infinite time to experiment, a grain of cosmic matter perfected through trial, error, and endurance. As Chapter 2 draws to a close, the weight of evidence leaves us suspended between wonder and discomfort. We are forced to consider that Atlas's chemistry is not an accident of birth, but a record of transformation. What began as ordinary dust may have become, through relentless exposure, something approaching intention, a material that behaves as though it remembers what it has endured. And as the telescopes continue to follow its path beyond Mars, scientists whisper a quiet acknowledgement. 3. Atlas is teaching us how little we understand about the matter that drifts between the stars. The trajectory of 3 Atlas is a paradox drawn in motion. When astronomers first plotted its path through the solar system, the numbers refused to behave. Its orbit was retrograde, moving opposite the rotation of the planets, and yet it was aligned within just 5 degrees of the ecliptic plane. That narrow alignment seemed too precise to be random, like a thread pulled perfectly across a spinning wheel. Statistically, such a configuration should occur only 2 times in 100. But Atlas had chosen that path exactly. It arrived not from a chaotic angle like most interstellar visitors, but as though it had traced the planetary plane deliberately. Its trajectory intersected the orbits of Mars, Venus and Jupiter with uncanny precision before sweeping toward its perihelion, the point of closest approach to the Sun, at the one moment when Earth's telescopes were least able to see it. For weeks, the Sun's glare made direct observation impossible. By the time at last emerged, it had already passed the point of greatest interest. The timing felt almost intentional. To the rational mind, this was coincidence layered upon coincidence, yet even the most skeptical observers admitted that it stretched the limits of statistical comfort. The orbit also carried peculiar energy signatures. Its hyperbolic excess velocity, how fast it moved relative to the Sun's gravity, matched values seen in previous interstellar visitors, confirming its origin beyond our solar system. But unlike Oumuamua or Borisov-Atlast's motion, exhibited subtle corrections as if responding to invisible hands of pressure or thrust. Each minor deviation sat just within the margin of observational uncertainty, frustrating any definitive claim. Still, the pattern remained small but consistent adjustments, nudging it along an almost optimized path through the planetary corridor. This optimization raised new questions. Was the path merely a fluke sculpted by the combined gravitational pulls of the inner planets, or did it hint at a deeper mechanism, something self-stabilizing within the object's dynamics? When analysts ran Monte Carlo simulations to test random orbital entries, none reproduced the same geometry. Even under the wildest initial conditions, the chance of such alignment remained infinitesimal. Nature allows miracles, but she seldom repeats them so neatly. The debate soon divided the community. Dynamicists argued that a retrograde path this aligned could result from long-term perturbations by galactic tides. If Atlas had been wandering for billions of years, its original vector might have been gradually bent until it matched our ecliptic by chance. But others countered that tidal forces act too slowly and too weakly to produce so precise an outcome. They pointed instead to the comet's own activity, the jets of gas venting from its crust, which could subtly alter its direction over time. Yet those jets, if they were the cause, would have had to push in perfect symmetry for eons. Such balance is elegant to imagine but difficult to believe. 3. Atlas's path through the inner system defied those expectations in another way. Its closest approaches to Mars and Venus coincided with points where gravitational interactions could have amplified any small error into a noticeable deflection. But the comet's course remained steady, deviating by less than a fraction of a degree. Even the encounter with Jupiter's massive field, which should have tugged at least slightly on its arc, produced almost no measurable change. The orbit seemed pre-calculated, as though the object anticipated every perturbation before it occurred. To astronomers watching from the ground, the movement felt eerie. Every time Atlas could have drifted, it didn't. Every time gravity invited chaos, it refused. The sense of witnessing precision in something supposedly natural unsettled even the most stoic analysts. One researcher described it as watching a feather fall in slow motion, yet always land exactly where physics says it shouldn't. As data accumulated, the retrograde nature of the orbit grew even more curious. A retrograde path is dynamically hostile. It invites collisions, tidal stress, and chaotic resonance. For an interstellar object to enter such an orientation and still survive its journey through the solar system without fragmentation borders on the impossible. And yet 3 Atlas not only survived, it thrived, maintaining its structural coherence and predictable emission cycles. If randomness had guided it, that randomness appeared strangely intelligent. The shape of its trajectory also bears resemblance to gravitational assist maneuvers used by spacecraft. Its curve through the solar system mirrored the multi-planet flybys engineered by mission planners to adjust velocity with minimal fuel. In Atlas's case, those assists seemed naturally embedded. It gained just enough energy from each planetary encounter to sustain its velocity, avoiding any direct collision or capture. It passed each world like a whisper, harvesting momentum but leaving no trace. When the simulation teams attempted to backtrack its journey, tracing its path into the void, they found another enigma. Instead of diverging wildly into the galactic background, Atlas's vector pointed toward a relatively sparse region, between stellar associations, a direction with no known origin of similar objects. If it were ejected from a planetary system, that system's remains have long since vanished. The void it came from is almost entirely empty, as though it had been travelling not from somewhere, but from nowhere in particular. The paradox compounds with every calculation. Either the orbit of 3 Atlas is a masterpiece of cosmic coincidence, or it conceals a physical principle we do not yet understand. Perhaps electromagnetic forces subtle and cumulative have guided its path across light years. Perhaps the interaction between its metallic content and solar radiation produces minute adjustments, a kind of natural ion sail mechanism. If true, it would mean Atlas navigates not through randomness, but through feedback, a self-correcting traveller using physics itself as propulsion. Whatever the cause, the result is undeniable. 3 at last moves as though it belongs here, gliding through planetary orbits with uncanny grace, then slipping away untouched. It leaves behind no debris, no scar, no gravitational echo. Just a question. How does something so ancient know exactly where to go? The next phase of observation will look for answers in the smallest details. Infrared mapping, radar echo profiles, and light curve analysis may yet reveal the internal structure guiding its motion. But as the data grows denser, so too does the sense of awe. 3. At last the object that should have wandered blindly through the dark instead moves with the elegance of purpose. And whether that purpose arises from physics coincidence or something deeper, it reminds us that the boundary between chance and design is often thinner than light itself. The first images of 3 at last's tail defied intuition. Comets by their nature are creatures of light pressure. Their tails stream away from the sun, pushed outward by solar wind and radiation. But in late July, telescopes in Chile and Japan recorded something unprecedented, a narrow jet of material extending toward the sun. It was faint but unmistakable, a streak of gas and dust flowing against the force that should have driven it away. Within hours, observatories worldwide confirmed the phenomenon. 3 at last was ejecting matter sunward, as if reversing the fundamental logic of celestial behaviour. To understand the impossibility of this observation, one must recall how solar radiation works. Every particle leaving the sun exerts pressure on whatever it strikes. For an object like at last, that pressure is relentless, sweeping volatile gases into long, radiant plumes that always point outward. Yet the jet captured in those photographs broke the rule. It didn't curve or twist. It extended directly toward the light, a luminous arrow fired into the solar wind. At first, researchers suspected optical illusion, perhaps a perspective effect or an interference pattern caused by viewing geometry. But triangulated data erased that hope. The jet was real, and it was active. At last's anti-tail lasted for nearly a week. Spectral analysis revealed that it consisted of fine dust particles and carbon-rich molecules much denser than the usual outflow from comets. What force could propel such matter against radiation pressure? Some proposed electrostatic discharge, a sudden build-up of charge within the crust, releasing in a focused stream similar to lightning in slow motion. Others imagined geysers venting volatile compounds through cracks, their pressure vectors simply oriented toward the sun by coincidence. But coincidence strains under repetition, and at last jet pulsed at regular intervals as though governed by rhythm, not randomness. In one striking observation, researchers noticed that the anti-tail appeared to align with the comet's rotation period. Every 247 seconds, a subtle brightening occurred like a heartbeat in the data. If this timing truly links to Atlas' spin, it implies a self-sustaining cycle of internal pressure build-up and release. That rhythm, coupled with the comet's metallic and organic crust, could create local fields capable of channeling the escaping gas. In essence, Atlas may have learned to exhale into the wind. To explain the physics models grew more exotic. Some teams suggested that the jet might arise from magnetic interactions between the comet's metallic grains and the solar field. If the surface carries residual charge or ferromagnetic inclusions, solar particles could induce a Lorentz force that shapes the outflow in unexpected directions. It would be the celestial equivalent of a compass needle turning against the storm. If verified, it would mark the first observation of electromagnetic self-guidance in a natural interstellar body. Yet even those theories struggle with scale. The pressure needed to push dust inward against the solar flux exceeds anything achievable by spontaneous venting. That means Atlas's interior must hold pockets of gas under immense confinement, sealed for eons beneath its hardened crust. When those chambers rupture, the release could momentarily overpower radiation pressure, launching jets in any direction. But that alone cannot explain the persistence of directionality. The the fact that time after time the venting aimed almost precisely toward the sun. As at last approached perihelion, the antitail grew shorter and then faded, absorbed into the glare. When the comet reappeared, the strange behaviour had vanished, leaving behind only data and questions. Did the jet signal internal asymmetry or something deeper, an unknown reaction between light and matter under extreme conditions? No one could say. Some researchers argued for natural asymmetry, others hinted at unknown material physics. Whatever the truth, it added a new entry to Atlas's growing catalogue of impossibilities. The philosophical weight of the phenomenon did not go unnoticed. To point a stream of matter toward the source of all energy is an act of defiance, or perhaps of longing. In the language of astronomy, it is just mechanics. In the language of metaphor, it is audacity, the shadow turning toward its maker. 3. Atlas once again blurred the line between observation and symbol. Its behaviour reminded the scientific world that nature is not bound by our expectations of symmetry. Even light itself can be met, resisted, or answered. In the quiet aftermath of the event, one astronomer summarised the sentiment shared across observatories. Every object teaches us something about motion, but Atlas teaches us about resistance, the will of matter to act against the stream. And so, the jet that defied sunlight becomes another riddle in Atlas' story. Was it pressure magnetism, coincidence, or a phenomenon yet unnamed? Whatever the answer, it transforms the comet from an object of study into a statement of the cosmos itself. Proof that even in a universe ruled by physics, surprise remains the most consistent law of all. When 3 at last reached perihelion, the point closest to the sun, its transformation was instantaneous and terrifyingly beautiful. For weeks it had drifted through the inner solar system like a black ember, dim, steady, cautious. Then, as the distance closed, it flared. The brightness of Atlas surged so violently that telescopes had to adjust exposure times by a factor of 100. In just 20 hours, its apparent magnitude rose beyond every prediction. A comet that should have been faint and ghostly instead became luminous enough to rival the sun's corona itself. At first, astronomers assumed a data error. Instruments occasionally misread brightness when a comet's coma expands suddenly. But secondary readings from the Siding Spring Alma and Solar Orbiter instruments confirmed the truth. Atlas had brightened by a factor of several thousand, too fast, too sharp, and too green. The spectrum revealed a surge in emission from ionized carbon and diatomic oxygen, producing a hue unseen in any natural cometary event. To the naked eye, if one could have looked past the sun's glare, the comet would have shone a vivid emerald against the black sky. The numbers strained physics. For a comet to radiate that intensely, it would need to release more energy than its mass could realistically store as latent heat. Sublimation alone could not explain it. No known process involving ordinary ices could drive such a leap in luminosity without disintegrating the nucleus. Yet 3 at last remained intact, its core stable, its orbital curve unchanged. It brightened without burning itself apart. The implications were staggering. Traditional comet theory predicts that the intensity of outgassing follows a predictable curve as solar heat penetrates surface layers. Atlas's curve was not gradual but exponential. Instead of responding to sunlight passively, it reacted, amplifying its own brightness as though catalyzed from within. For a brief period, the light curve formed an almost perfect sigmoid, a shape characteristic of self-regulating systems in biology or electronics, not celestial mechanics. No one had ever seen anything like it. Spectroscopic data captured during the flare revealed strong emissions near the 557.7 nanometer line, a wavelength typically associated with atomic oxygen fluorescence. But the intensity was hundreds of times greater than standard models predicted. The chemical composition of the outflow matched a process far more energetic than thermal evaporation, possibly photodissociation of organics under extreme charge conditions. The comet was not merely evaporating, it was converting energy, turning absorbed radiation into coherent luminescence. This idea, once dismissed as fanciful, gained traction when further data showed periodic flickering synchronized with the 247-second rotation signal already noted earlier. Every rotation, Atlas's brightness pulsed, as if inhaling and exhaling light. The rhythm was so consistent that it resembled a heartbeat rendered in photons. It was not a random flare, it was a pulse. Such regularity forced scientists to question whether the process might be electromagnetic rather than purely thermal. If Atlas's crust contained conductive materials as previous metallic readings suggested, then it might behave like a giant photonic capacitor. Charged by solar radiation, its surface could store potential energy, and then discharge it periodically, releasing bursts of ionized gas and photons. That would account for both the rhythm and the impossible luminosity. But even this hypothesis carried contradictions to sustain that much charge. Without tearing itself apart, the comet would require a degree of internal cohesion beyond any known material. Once again, the data seemed to hint at design, though no one dared to use that word aloud. As the brightness peaked, another mystery emerged. At the expected thermal limit, the comet should have shed vast quantities of dust, billions of tons forming a broad diffuse halo. Instead, observations showed the opposite. The halo thinned, the tail sharpened, and the surrounding dust cloud diminished. 3I Atlas appeared to consume its own debris, drawing light inward even as it radiated outward. Its radiance paradoxically came with silence. Ground-based observers watched helplessly as their instruments approached saturation. Some compared the event to the sudden ignition of a controlled reaction, a cosmic combustion in slow motion. Others suggested that the green glow might signify complex plasma chemistry, carbon monoxide and oxygen recombining in a cascade of energy release. But the most unsettling aspect was not its colour or intensity, it was its restraint. The flare plateaued, stabilised, and then slowly declined. No explosion, no fragmentation, just a return to calm, as though the comet had completed a deliberate act. When the flare subsided, the comet's apparent magnitude fell again to near its original levels. Yet its surface albedo, its reflectivity, remained permanently altered. Where it had once been pitch dark, its crust now reflected nearly 10 times more light. In effect, Atlas had polished itself. Spectral data showed a fresh layer of condensed gases on its outer surface, perhaps the residue of an internal eruption that had sealed the body anew. It was as though the comet had shed its skin and grown another in the same instant. To astronomers, the implications were almost spiritual. They had witnessed a transformation that felt less like a mechanical reaction and more like an awakening, a transition from dormancy to expression. And yet the instruments had no sentiment, only data. The light curve remained, the oxygen lines persisted, and the universe continued without commentary. Still, for those who watched the moment, carried weight. It was the first time humanity had seen matter respond to the sun not with decay, but with renewal. In the weeks following the event, research teams worldwide began reanalyzing the data. Could the flare be explained by resonance between solar wind frequencies and the comet's rotation period? Could electrostatic discharge account for the glow, or had at last become a lens focusing sunlight through its own dust? Each hypothesis found support and each failed in turn. For every explanation, the object offered another contradiction. Atlas's brightness surge remains even now one of the strangest events in modern astronomy, a flash of order where chaos should have ruled. It broke no physical laws, yet it made them feel incomplete. It acted as if it knew its own limits and reached them carefully, deliberately. In the silence that followed, scientists were left not with answers, but with awe, a feeling that somewhere in the interplay between light and matter, 3 Atlas had reminded us that nature still keeps secrets we're not yet ready to name. After the flare faded, astronomers turned from light to motion. Brightness could deceive, but trajectory could not. 3 Atlas, despite all its radiance, should have continued along a predictable arc under the sun's gravity. Instead, the orbit began to drift slightly at first, then unmistakably. The deviation measured only a few arc-seconds, barely perceptible to casual instruments, yet for precision astronomy it was seismic. The comet was accelerating in a way that gravity alone could not explain. This was not the first time such behaviour had been observed. Oumuamua I, confirmed interstellar visitor, had also deviated from its projected path. Then scientists attributed it to outgassing jets of vapour pushing gently against its surface. But Atlas's case defied that reasoning. Its outflow had been minimal, even self-contained, during the brightness flare. There was no evidence of powerful jets capable of altering its course, yet calculations confirmed the acceleration a consistent shift, equivalent to several millimetres per second, squared small in human terms, but enormous in the vacuum of celestial mechanics. If the cause had been a burst of sublimation, telescopes should have recorded a vast cloud of expelled material. They found none. The predicted 5 billion tons of gas and dust were missing. Even the most sensitive infrared and radar scans detected no residual plume. At last had changed its velocity as if pushed by an invisible hand. The first hypothesis to surface was the classic one asymmetrical outgassing. Perhaps the comet's inner chambers released gas in a narrow direction, producing thrust without visible debris. But for that to account for the acceleration, At-last would have had to lose a massive portion of its weight, around 15% of its total mass. That would have transformed its shape, altered its spin, or fragmented its nucleus. None of these signs appeared. Instead, At-last emerged from perihelion almost unchanged, spinning with the same measured rhythm as before. The data did, however, show something subtle, a phase shift in its rotation cycle, a slight offset of 2 seconds from its pre-perihelion value. That variation might hint at an internal redistribution of mass, like a gyroscope rebalancing itself. Some scientists interpreted this as evidence of internal caverns collapsing or sealed gas pockets shifting within. Others suggested electromagnetic coupling between the comet's metallic particles and the solar magnetic field, an interaction that could under certain conditions produce minute but continuous thrust. If true, At-last was being steered not by explosion but by physics, an ion-scale propulsion invisible to human eyes. The most compelling evidence for this theory came from ALMA's submillimeter observations. The instruments detected slight variations in radio flux consistent with ionized material streaming in a directed pattern behind the comet. Yet this stream was neither large enough nor bright enough to qualify as a visible tail. It was faint, almost ghost-like, a controlled whisper of motion instead of a roar. It seemed as though At-last was adjusting its course with precision, not violence. The effect also aligned suspiciously well with the timing of the brightness flare. As the luminosity increased, the trajectory shifted, then stabilized when the light faded. This synchronization implies a connection between the radiant energy released and the acceleration experienced. Energy was not merely escaping, it was being converted, redirected, perhaps even harnessed. In a sense, At-last's flare might have acted as a propulsion event, one that traded light for motion. Such an interpretation borders on heresy in conventional physics. Natural bodies do not convert energy intentionally. They react passively to forces, and yet 3 At-last's behavior fits none of the passive models. It brightened without disintegration, accelerated without expulsion, and maintained internal order throughout. Whatever mechanism drove it, it operated with the precision of control rather than chaos. When researchers tried to model the phenomenon, most scenarios failed. Thermal recoil forces could not account for the direction of acceleration. Electrostatic discharge required voltages too high to survive structurally. Even radiation pressure from the sun, powerful though it is, proved too weak to produce the recorded effect. The only explanations left were either unknown material physics or interactions on a quantum scale beyond current measurement. One paper quietly proposed the possibility of photonic resonance, where internal microstructures absorb and re-emit light in ways that generate recoil. If correct, At-last would effectively use sunlight as a sail, not with fabric or foil, but through the very nature of its surface. As the comet receded from the sun, the anomaly persisted. Weeks passed, and still its velocity remained slightly higher than predicted. The further it moved into the cold, the more constant the deviation became, as though the mechanism had stabilized into a steady thrust. If it were mechanical, it was continuous. If natural, it was enduring. At-last seemed to glide on invisible rails, following a curve that defied gravitational simplicity. Scientists across agencies, the European Space Observatory, NASA JAXA, held late-night conferences comparing their models and finding the same void. The missing mass cloud remained missing. No plume, no halo, no expanding debris field. At-last had gained momentum from nothing measurable, leaving only an absence where physics expected substance. The silence of that absence became as loud as the brightness that had preceded it. For some, the data stirred discomfort deeper than curiosity. In every known instance of cometary acceleration, the cause could be traced heat gas impact gravity. At-last offered none. It moved as though guided by intention or by a principle hidden within the mathematics of light itself. No one claimed it was artificial, yet the pattern carried echoes of precision familiar to human engineering. And so the scientific language grew careful words like resonance feedback, self-regulating mechanism, phrases that walked the edge between natural and deliberate. There is something haunting in that caution. When we encounter behavior that mimics control, we hesitate to call it coincidence. Perhaps At-last embodies the deeper symmetry of the cosmos, where even the unthinking finds patterns of efficiency. Or perhaps it is simply the first of many such travellers teaching us that interstellar matter obeys rules we have yet to write. By early November, the comet's motion began to normalise its acceleration tapering off. The trajectory stabilised into a graceful arc leading outward toward the edges of the solar system. The missing cloud was never found. What remained was data cold, clear, defiant. Atlas had proven that something invisible could move a body through space, and in doing so it had written a new equation in the margins of celestial mechanics. For astronomers watching from Earth, the meaning of that equation lingered long after the object faded from sight. It was not merely a question of what had propelled Atlas, but of what it revealed that motion like light might still hide unknown forms of order. And as Atlas slipped once more into the dark, its green glow fading to nothing, it left behind an image not of destruction, but of quiet, perfect defiance. An object that challenged gravity radiance and our assumptions about both. 3. Atlas was gone again, but its absence burned as brightly as its passing. By the time 3 Atlas had left the inner solar system, its behaviour had forced the scientific world into quiet crisis. Every principle that defined cometary physics, gravity sublimation, momentum, conservation had been tested and found insufficient. Data did not contradict the laws of nature, yet the object behaved as though it operated just beyond them, like a student solving equations with a method the teacher had not yet invented. The challenge now was not observation but interpretation. How could something so consistent still lie outside every known framework of explanation? The first attempt at reconciliation came from the conservative camp. Atlas is a comet, nothing more. Its metallic ratios, negative polarization, brightness flare and non-gravitational acceleration were all, they argued, edge case phenomena compounded by rare coincidence. Stack enough improbabilities and you get the extraordinary. It was a comforting position, an appeal to statistical humility. But when the models were pushed to their limits, the probabilities collapsed. The odds that all these anomalies would occur in a single object by random alignment of natural variables dropped below 1 in 10 billion. Statistically possible, yes. Scientifically satisfying, no. More radical voices proposed that Atlas might not be a comet at all, but a new category of interstellar matter, neither rock nor ice, but something in between. Perhaps a body formed in the magnetic fields near a galactic core where gravity radiation and plasma flows create hybrid structures unknown in our neighbourhood. Such an environment could in theory produce an object with internal magnetic coherence, allowing it to interact dynamically with sunlight and solar wind. In that case, Atlas' decisions would be the emergent behaviour of physics itself, a form of responsiveness without consciousness. Nature, after all, has always been the greatest engineer of complexity. Yet the problem persisted: coherence. Natural randomness should leave scars: chaotic rotation, asymmetric venting, erratic photometric signatures. 3 I-Atlas displayed none. Its spin period remained constant, its light curves repeated with near-machine precision. Even its faint acceleration profile traced a smooth exponential decay, as if regulated by feedback. Randomness by definition does not regulate. That was the paradox tearing through the scientific community. If Atlas was natural, it was the most disciplined accident ever recorded. If it was not natural, then the universe had just introduced a concept no one was prepared to name. Some theorists began to frame the debate in new terms. Instead of asking whether Atlas was artificial, they asked whether our definition of natural was too narrow. Perhaps self-organizing systems could emerge not only in biology, but also in matter subjected to extreme timescales and energies. A rock given billions of years and exposure to galactic magnetic fields might evolve structural memory patterns of response, encoded in its crystalline lattice. In this view, Atlas's precision was not design but inheritance, the fossilized behavior of physics over unimaginable time. A relic not of intention, but of persistence. This hypothesis, nicknamed the memory stone model, posits that interstellar bodies may develop feedback loops between energy absorption and emission, stabilizing their trajectories the way ecosystems stabilize through balance. A comet that learns to redirect energy efficiently would survive longer, drift farther, and appear almost intelligent. Atlas then could be seen as an ancient survivor, not a messenger. It did not come to tell us something. It simply is something, an existent proof of matter capable of adaptive equilibrium. Skeptics quickly countered that such reasoning bordered on metaphysics. No known physical process allows for learning without consciousness or computation. Yet as data accumulated, even skeptics struggled to maintain distance. When the same self-regulating patterns emerged independently in Atlast's luminosity and motion, the coincidence demanded explanation. Coincidence, one scientist wrote in frustration, is a placeholder for ignorance. The conversation began to shift. NASA's Jet Propulsion Laboratory convened a series of closed-door workshops titled Beyond Stochastic Models. The agenda to explore whether known forces, when arranged in nonlinear feedback networks, could mimic the behavior observed in 3I Atlas. Preliminary simulations suggested that under precise conditions, metallic inclusions, rotating electric dipoles, and asymmetric heat conduction, self-stabilizing motion might indeed arise. But those same simulations required parameters so fine-tuned that nature would have to aim with mathematical precision. Even when the results fit, they felt hollow, like trying to explain poetry with arithmetic. Meanwhile, other groups approached the problem from a philosophical angle. Perhaps the crisis was not in the comet, but in the language used to describe it. Physics, after all, is a translation of nature into human syntax. When an object like Atlas refuses to fit that syntax, it exposes the limits of the language, not necessarily the reality. As one cosmologist phrased it, Atlas doesn't break physics, it breaks the way we speak about physics. That thought echoed beyond laboratories and journals. In the quiet moments between data streams, observers began to feel something unusual, a sense of dialogue. Atlas, in its silence, had become a teacher. Its every anomaly felt like a question posed directly to human understanding. How complete are the laws we claim to know? How many truths lie hidden because our instruments are not built to ask the right questions? The answer may not lie in the equations, but in perspective. For centuries, humanity has treated the cosmos as an object of study. But perhaps Atlas reminds us that we are also part of the experiment participants, not observers. If matter can retain the memory of forces, then so can we. If the universe can generate order from chaos, perhaps consciousness itself is one expression of that same mechanism. 3. Atlas, in that sense, becomes a mirror, not of alien intelligence but of our own evolving humility. It challenges the notion that everything unknown must be either error or miracle. It sits in the narrow band between explanation and mystery, where science and wonder coexist without conflict. And maybe that is its true significance, not what it is, but what it compels us to become. As Chapter 5 draws to its midpoint, the paradox remains unresolved. Atlas continues outward silent and indifferent, while Earth's brightest minds chase after the meaning it left behind. For every question answered, two more emerge, and in that endless recursion lies the quiet truth of discovery that the universe's greatest brilliance is not its order, but its refusal to be fully known. When the first comprehensive report on 3I Atlas was released, the scientific community expected resolution. Instead, it delivered a paradox wrapped in precision. The data were flawless. The conclusions were not. Everything observed, its anomalous orbit, metallic ratios, polarization, reversal, brightness surge and non-gravitational acceleration, was real, verified and cross-checked across independent observatories. But when these fragments were assembled into a single coherent model, the mathematics dissolved into contradiction. Every variable fit, but the picture they formed did not exist in nature as we understand it. It was like building a puzzle that perfectly locks together, yet reveals no image, only abstraction. Scientists began calling it the statistical mirage. Individually, each anomaly could be explained through known physics. Collectively, they cancelled one another out, forming a system that balanced at zero probability. In probability theory, such an outcome is nearly impossible without deliberate constraint. Yet there it was, a celestial object, whose observed behaviours formed a pattern so internally consistent, it mimicked design while remaining ostensibly natural. The term mirage was more than metaphor. It suggested that perhaps the coherence we saw was an illusion born from perspective. Maybe Atlas was not exceptional. Maybe we were positioned at a uniquely deceptive vantage. Our instruments orbiting one tiny planet had captured a narrow window of its life cycle. What if the anomaly existed only because we saw too little? Just as a desert traveller sees water where there is none, we might be seeing pattern in noise. It was a comforting theory, and for a time it held. But then the pattern persisted. Months after perihelion, as Atlas retreated into the outer solar system, new readings from the Deep Space Network confirmed that the same 247-second pulse still echoed faintly in its emissions. The light curve remained rhythmic, undiminished by distance. The probability of such persistence, if random, was infinitesimal. The mirage refused to fade. At that moment the debate fractured. One side insisted that the human mind wired for narrative was fabricating order from chaos. The other argued that the order was objective and demanded acknowledgement. The tension between those positions mirrored the ancient rift between empiricism and philosophy, the same argument that has haunted science since its birth. 3 Atlas had resurrected it, forcing both sides to confront the uncomfortable possibility that truth may exist in degrees not absolutes. To dissect the mirage, mathematicians introduced a new model, dynamic probability field theory. It treated Atlas not as a fixed object, but as a fluctuating statistical entity whose behavior emerges from overlapping causal domains, thermal, magnetic, gravitational, and quantum. Each domain influences the others, creating resonance zones, where improbable events become transiently likely. In such a framework, the comet's coherence could arise naturally not from purpose, but from the statistical sweet spots where physics temporarily self-organizes. The theory was elegant, but its beauty carried a price. It required abandoning linear causality. Events no longer followed neat chains of cause and effect, but swirled in loops of feedback and probability. It was not just Atlas that defied order. It was our assumption that order must always flow forward. Some found liberation in that idea, others found discomfort. If the cosmos allows feedback to shape matter, then predictability itself becomes an illusion, a convenient simplification for human minds incapable of holding the whole. Atlas might not be exceptional. It might simply be honest, revealing what the universe truly is when unfiltered by our need for continuity. A team from the European Southern Observatory ran a series of simulations based on this model. They discovered that when matter rotates within variable electromagnetic fields, like those found in the galactic plane energy exchanges, can produce self-stabilizing feedback. Under certain conditions, these systems exhibit preferred states configurations that repeat spontaneously. In nature, these are rare but not impossible. The difference with Atlas was magnitude, the coherence sustained over astronomical scales, far beyond any model's expectations. If the simulations were correct, then Atlas was not an exception. It was an exemplar, the first observed case of macroscopic resonance in interstellar matter. The universe, in other words, may not be random at all. It may be rhythm pretending to be chaos. The implications were profound. If feedback resonance could stabilize motion, it might also shape structure, chemistry, even time itself. Matter would no longer be passive. It would participate in its own persistence. 3 Atlas could thus represent a higher form of material autonomy, matter learning not by intention, but by resonance, not intelligent but self-consistent, not alive but awake enough to endure. Still, skeptics refused to yield. They argued that the elegance of these theories risked romanticizing ignorance. Until direct sampling confirmed such feedback, the model remained a philosophical patch, a way to make anomalies feel comfortable again. Their counterpoint was stark. If Atlas cannot be explained by known physics, then it must still obey unknown physics, not imagination. But that assertion failed to erase the disquiet. Even the skeptics could not ignore the statistical perfection of the data. Every measurement repeated with a precision that mocked the randomness they claimed to defend. The crisis deepened when a final review by the International Astronomical Union revealed something almost poetic. When plotted across multiple datasets, luminosity, velocity, polarization, and spectral composition, the variations all synchronized in near harmonic ratios 2, 3, 5, 8. Those are Fibonacci intervals, the mathematical fingerprint of growth balance and self-organization in systems from seashells to galaxies. No one could claim coincidence without blushing. The numbers spoke with the clarity of music, and their melody whispered a word science is trained never to say: pattern. At that realization, the tone of the discussion changed. Not triumph, not panic, but quiet recognition. The line between random and deliberate had grown indistinct. Perhaps Atlas did not exist to challenge physics, but to remind us of its deeper symmetry, the one that connects chaos to structure, entropy to emergence. In that symmetry, the improbable becomes inevitable, not because it is planned, but because the universe favors beauty disguised as probability. One astrophysicist, writing anonymously in a peer-review draft, summarized it best. We have spent centuries believing that meaning requires mind. Atlas suggests the opposite, that meaning is what matter becomes when it endures long enough. In the months that followed, the world's attention drifted elsewhere, new discoveries, new missions, but among those who had watched Atlas from its first appearance, something fundamental had shifted. The object was gone, but the question remained pulsing quietly in the human mind like the echo of its 247-second rhythm. Was 3. Atlas truly exceptional, or was it simply the first time we had looked deep enough to see the intelligence already woven into the laws of nature? Perhaps in the end the mirage is not in the data but in us, the illusion that understanding must always mean control. Maybe Atlas is proof that the universe does not hide its mysteries, it reveals them slowly in motion,